Night settles without hurry, and a pale current of light pours from horizon to horizon. The old river of the Milky Way hangs there, a faint frost across black glass, while the world beneath turns under it without sound. A soft welcome rises and recedes. Somewhere off stage, a wish for comfort is quietly offered, and a small invitation to support the voyage, a like, a subscription, a promise to return, drifts by like a leaf on still water. A gentle question takes its place. How does a species live inside a galaxy for so long and only slowly learn what a galaxy is? What looks like mist is not mist. The luminous band is the integrated glow of uncountable stars seen edge on through the thin disk that also carries the sun, their light braided with lanes of interstellar dust that both sculpt and conceal. Dark rifts split the stream because tiny grains, silicates, carbon, ice-coated fragments, absorb and scatter the shorter, bluer wavelengths, letting redder light slip through with less loss. This is ordinary physics written large, extinction and reddening stretching across a sky, turning a stellar city into a cloud to the unaided eye. A lesser-known light comes forward, not in the galaxy, but near at hand. Opposite the sun, a delicate oval sometimes blooms around midnight, a backscattered glow called the Gegenschein. It rises from dust in the solar system, returning sunlight toward its source, so faint it vanishes in the presence of any hurry. The oval can coax a newcomer into thinking the Milky Way has a wrinkle there. It is a reminder that night holds layered lights, and the eye drifts among them with quiet assumptions. There is irony in every direction. The brightest river asks for the darkest ground, and modern brilliance on the horizon erases ancient starlight with perfect efficiency. A single step away from a street lamp changes nothing about those distant suns, yet changes everything about how many can be seen. And it only took a species the long road from campfires to observatories to learn that what the eye cannot count can still be measured by gentler means. A watcher learns to read gradients. Toward the constellation-rich center of the band, the shine thickens. Toward its edges, it thins. This is an imprint of the Milky Way's flattened disk and inner bulge, not a mood of the air. Under dry, dark skies, the unaided eye reaches only to a limiting magnitude of roughly sixth magnitude. Beyond that threshold, stars merge into sheen, and counting yields to inference. The limit is not a failure of biology. It is a boundary that becomes a tool, the line where sight hands its question to method. Darkness is not empty. The lanes that seem to erase the river actually record cold molecular clouds, mostly hydrogen and helium with a trace of heavier dust, so chilled that their temperatures hover only a little above the background of space. Within those same clouds, stars will someday ignite. For now, they appear as absence. One can walk toward a dark gap and never arrive. It rides overhead with Earth's rotation, a reminder that distance in the sky is angle, not meters, and that stillness on the ground does not halt the moving dome. Uncertainty remains, not as a flaw, but as a texture. The exact tracing of the Milky Way's spiral arms continues to shift as new surveys weigh different markers. Clusters of newborn stars here, dense dust lanes there, radio-bright hydrogen farther out, and the maps do not always agree. The barred core that stirs the inner disk shows itself in motions and star counts, yet its precise length and tilt relative to the sun's line are tuned and retuned as catalogs grow. The outskirts lift and dip in a gentle warp like a shallow swell, and the causes, retained tides from encounters, ongoing pulls from satellite systems, the broader influence of the halo, keep their edges soft. A quiet analogy arrives and then leaves. The band looks like the blurred ring road of a distant city seen from a slow train at night, nearby lamps smearing into streaks, far neighborhoods melting into a pale wash, dark overpasses carving sudden gaps. The image helps, and it misleads. A city burns fuel by choice. A galaxy shines because gravity and time arrange hydrogen into fire. A train returns to its station in minutes. The sun circles the galactic center in hundreds of millions of years. Yet the sense of being inside a structure and not at its edge remains useful, a local feeling that gestures toward an immense architecture. History stands nearby, patient as a tide. For centuries, charts depict the Milky Way as a painted river. For as long, poems treat it as weather of the upper sky. The recognition that the band is stellar gathers by degrees and spreads across generations, while the question of what lies beyond, those faint spiral smudges scattered elsewhere, waits its turn. The night hosts conflicting interpretations. Without complaint, offering the same band to every era and letting conclusions rise and subside with the constellations. Even without names and numbers, the scene yields to a calm eye. The glow strengthens toward the galactic center because more stars crowd that direction. Dust lanes cut sharply because grains a fraction of a micron wide scatter blue light far more than red. The sheen itself grows and thins with altitude because the atmosphere belongs to the instrument as surely as glass does. The observer is not outside the apparatus but inside it, and the apparatus is planet, air, eye, and mind together, a quiet collaboration that learns by standing still. The opening question remains where it was placed. How could misunderstanding last so long? It lasts because line of sight manufactures illusions as faithfully as any mirage on a road. It lasts because instruments grow by careful increments while the object under study stays enormous. It lasts because each improvement reveals more structure and, with it, more ways to be slightly wrong. None of this troubles the sky. The river flows. The planet turns. Watchers arrive and depart, and the band keeps its pace, steady as a breath. There is time enough. The river will still be there when the story reaches for glass and begins to sharpen haze into points. For now, the world lies quiet beneath a brightness that seems simple and is not, and the sky continues its old work of sending ancient starlight, through dust, through air, through pupil, to the back of an eye that has only lately learned how to remain dark long enough to see. A small tube of glass takes the sky apart. The hazy river that once seems like spilled milk now surrenders its texture. Where the unaided eye reads cloud, the magnified eye reads a crowd of points. Through early refractors, the Milky Way resolves into innumerable stars. The smooth band, turning grainy as if a sheet of frost is discovered to be a field of separate crystals. It is a simple act of collecting more light across a wider pupil and bending it to a sharper focus. Yet the consequence is a change of category. Not vapor, but city. Not weather, but structure. He turns lenses by hand in a quiet room, then aims them toward the band. The instrument is modest, a narrow refractor, a few finger widths across, a few tens of diameters in magnification, but it is enough. The Pleiades that once carry 6 or 7 visible lights now flower into dozens. The beehive in Cancer, long nicknamed a mist, splits into a swarm. The Milky Way itself breaks into stardust that is not dust. A scientifically accepted truth comes to rest. The band is stellar, a line of sight through the thin disk of the galaxy, thickened by foreshortening and darkened by interstellar grains that prune the blue. Optics have their own weather. Early singlet lenses scatter color into fringes so that bright stars wear faint rainbows, and the edges of the field soften into a gentle blur. Later, achromatic pairs will tame that prismatic spill, and mirrors will gather still more faintness without splitting it into color. For now, the glass is enough to teach a lesson as old as sight. Brightness and structure emerge when aperture grows, and counting proceeds farther when the threshold moves. The unaided eye stops near magnitude 6. A small telescope reaches deeper, and the smooth becomes granular in an instant. A small, lesser-known detail tucks itself into the scene. Where the cross of the southern sky rises, invisible to northern observers for centuries, a black lagoon stands against starshine, the coal sack, a dark nebula cut into the band like a thumb pressed into snow. In early telescopes, it remains dark because there is nothing wrong with the glass. There is only dust in the way. The void is not empty, it is full of micron-wide grains that absorb and scatter light, and beyond them the river continues, unseen but not absent. Uncertainty sits, nearby untroubled. The telescope resolves the band, but not the scale. Parallax, the tiny shift of a star's position with Earth's orbit, has not yet been measured. The stars are still distance without number, points without yardsticks. The Milky Way is proved, a field of suns, and yet its size, shape, and our place within it remain conjecture, a map drawn with one coordinate missing. Even the nature of other blurs, the little spirals and ovals catalogued as nebulae, is undecided. Some will be clusters, some clouds of gas, some galaxies beyond. The tube tells the difference only sometimes. A first soft irony settles. A tool built to see nearby ships coming over a sea horizon ends up dissolving a celestial sea into stars. A second follows behind it without hurry. By making the Milky Way less cloudy, the telescope makes the universe more cloudy, because every point it adds is a new question whose distance and motion must be learned. A third takes shape as a dry smile. The instrument that gives the sky more stars also takes away myths and must leave them somewhere. In exchange, it offers uncertainties, with better optics. The process is gentle, almost household simple. 2 curves are polished into glass, a narrow tube keeps stray light from the eye, and the whole assembly collects a cone of photons that would otherwise pass by. The focal point gathers them into a ratio of separation and breadth, and the eye, itself a lens, receives a contracted image of a larger portion of the sky. Under this arrangement, crowded fields stop blending. Stars just below naked eye threshold step forward like quiet guests crossing a doorway. The act is mechanical and patient. No drama is required to change how a river looks. Line of sight geometry does the rest. Along the plane of the galactic disk, the path through the stellar population is long, so the sum of faint lights builds into a sheen. Away from the plane, the path shortens and the sheen thins. Dust lays dark lanes through the band, and the telescope, faithful to physics, makes those lanes sharper while preserving their absence of stars. Seeing into the band is not only about magnification, it is about removing blur until the eye accepts that nothing has been blurred away there at all. The darkness is not ignorance. It is interstellar chemistry blocking a view. An analogy arrives softly and stays only as long as needed. The Milky Way under magnification looks like a coarse newspaper halftone brought under a loop. The picture breaks into dots, and the mind recombines them into an image while remembering the dots are real. The analogy is helpful, and it misleads. A printed page is planned, a galaxy is grown. The halftone has a fixed screen. A star field changes density with radius and spiral arm. Still, the sense of pattern emerging from points is enough to let the eye relax around a new truth. The quiet of early observatories matches the sky. Wooden tripods absorb the tremor of breath. Clockwork drives are still a dream. The Earth's rotation slides the field slowly, making the stars flow like a mild current across the glass. He marks what he can. Positions relative to brighter anchors, counts within small boxes of sky, the shapes of fogs that refuse to resolve. Instruments of the hand create catalogues of the hand, and those catalogues become footholds for others to climb. The river above yields to a grid below, and a kind of cartography begins. A second, more intimate detail lingers on the edge of the lens. The starfield next to Orion's sword shows a smoky light that resists complete resolution even in good glass. It is the Orion Nebula, a real cloud of ionized gas where newborn stars carve cavities and set the hydrogen glowing. The telescope both dissolves and confirms the mist. Some light is granular, some is truly nebulous. In this coexistence, misunderstanding keeps a foothold because the mind prefers one category at a time. The sky insists on many. Another quiet uncertainty keeps its voice low. How much of the Milky Way's brightness comes from stars one by one, and how much from light scattered by dust back into the line of sight? The balance is known in principle and tested by color and polarization, but early glass cannot separate it cleanly. Later, spectroscopes will show emission lines in true nebulae and continuous spectra in star clouds, and later still, infrared and radio will walk past the dust. For now, the eye lingers in a regime where categories overlap and patience is the main instrument. The ironies keep their soft company. An entire culture's star lore fits in a human mouth, yet the number of stars now visible no longer fits in a voice. A myth can cross a continent in a generation, but a parallax measurement waits for steadier mounts and better micrometers, a precision that takes centuries to arrive. And while the telescope satisfies the simple question, mist or stars, it expands the simple answer into a long syllabus. Optics, geometry, photometry, extinction, and the practical art of keeping dew off a lens at midnight. He adjusts focus and the band snaps from blur to grain, a small, almost domestic click of clarity. The glass has no opinion. It only obeys refractive index and curvature. The sky has no preference. It only supplies photons according to distance, temperature, and dust. The understanding grows because the person at the eyepiece holds those two indifferent gifts in one mind long enough to notice their agreement. The Milky Way changes not at all under this attention, and yet it changes completely, because it is now a set of counted things. The night continues its slow turn. Stars flood the field and drift out of it. The band brightens toward its center and thins toward its edges. Dark lanes hold their ground. A fact has been established. The river is made of suns. A detail has been noticed. Some darkness is matter, not emptiness. A mystery remains. Scale and structure still float without anchors. In the space between those three, a pathway opens for the next step, where counting becomes mapping and the grain of a field becomes the contour of a whole. Maps take shape from counting. He points the tube not to beauty but to statistics, lets the field drift, and tallies the stars that cross a fixed eyepiece frame. Region after region, the totals rise and fall, and from those quiet undulations he sketches a structure that cannot be seen all at once. This is stargaging, converting number into depth by assuming that stars are sprinkled with roughly uniform density and that the instrument reaches the same limiting magnitude in every direction. The work proceeds slowly, circle by circle, as if the sky is sifted through a mesh held steady by breath. A scientifically accepted truth gathers like dew on the lens. Counts along many lines of sight reveal a disk-like distribution for the Milky Way. The tallies trace a lentil more than a sphere, a shallow system whose longest dimension lies in the plain where the night's river runs. Within this map, the sun appears near the middle, not because nature votes for symmetry here, but because the assumption of uniform transparency makes every window look equally clear. Later, interstellar extinction will be named and measured. In this moment, the counting is clean, the path of sight imagined as open. A lesser-known detail rests beside the ledger of counts. The great speculum metal mirrors of the age, copper mixed with tin, polished until a face swims in them, tarnish as they meet the damp breath of night. Reflectivity fades, figure softens, and the observing plan must make room for polishing, repolishing, and the gentle art of catching a clear sky between two dullings. In the yard where the instrument waits, a ladder rises and a wooden chair tilts. Canvas keeps dew from the tube. A lantern is hooded so thoroughly that its light is only a suggestion. The mirror is an obedient thing with a short memory of brightness, and so the notebook acquires a rhythm shaped as much by chemistry as by stars. Uncertainty keeps close company and declines to take offense. The star counts presume that the telescope reaches the same depth in Sagittarius as in Monoceros, through the bright bulge as through the outskirts, and that is not quite true. Dust along the line of sight prunes the faintest stars to invisibility, and in those directions the gauge reads low. The disk seems to end where the dust begins. The sketched shape is therefore less a contour of stars than a contour of transparency, and both are real. Hidden structure, like spiral arms and a central bar, still waits behind the pruning, present in motion and birthplaces, absent in the sums that stop at faintness. Soft ironies arrive like small birds and settle without fuss. To center the sun. In a galaxy, one need only believe the windows are all equally clean. To draw the edge of the universe, it is enough to draw the edge of the instrument's reach and call it far. And to make the Milky Way look thin, one merely has to notice that counting is easiest where darkness is least. Yet the work is not wasted, even with its biases. Gauging writes down a disk, a bulge, and a thinning away from the plane. It shows that the river is not merely a pleasing weather band, but a structural fact. A long, shallow lens of stars. The counts run higher toward the band and lower toward the poles. They climb toward Scutum and Sagittarius, and dip where wide dark lanes cut the glow. Geometry, not legend, shapes the picture. The process is simple to describe and heavy to perform. Choose a field, time the drift, count the points, note the total, move on. By repetition, a cross-section of the galaxy gathers on paper, each line a thin accumulation of patience. A quiet analogy helps and then backs away. It is as if someone standing inside a vast forest counts trunks within the circle of a lantern in every direction. Where the count is high, the forest is thick. Where low, it thins. But if fog lies in some directions and blocks the more distant trees, the count will fall there not because the world changes, but because the path of sight does. The lantern is the telescope. The fog is interstellar dust. The conclusion is true, in outline and softened at the rim. Another detail of craft glows faintly. The field of view is measured by timing how long a star takes to drift across under Earth's rotation, turning the planet into a calibration weight. Sidereal time becomes a ruler. The sky's slow spin writes numbers in the notebook. In this way, the eyepiece circle acquires a diameter in arc minutes without a micrometer, and a count per circle translates to a density per portion of sky. The method requires steadiness and a willingness to let the heavens move while the hand stays still. Even the cold becomes part of the instrument, tightening wood and metal until focus snaps into its place. The mystery that lingers is modest in phrasing and immense in consequence. How far do these stars go, and what is their true distribution when darkness is accounted for? The counts whisper of a center, but its distance stays unmeasured. They hint at thickness, but no scale height is certain. The outline looks smooth, yet spiral structure hides beneath, filtered by dust and distance into an evenness that is only apparent. Spiral arms, a central bar, and the gentle warp of the outer disk remain indistinct in this era of tallies and inference, the way a coastline remains guessed at when seen only in fog. Irony keeps its soft tally. The grandest instrument of the yard, the towering long-focus reflector that draws visitors by daylight, proves less useful for this work than smaller, steadier tubes, because too much focal length magnifies tremor and narrows the view. The very success of counting can make the eye less sensitive to surprise, as neat columns replace astonishment with variance and error bars. And the most human limit in the experiment is not optical at all. Fatigue lowers the limiting magnitude, long before physics does, so the same glass sees less at dawn than at midnight. Still, a map forms. It is crude and brave, with the Sun near the center of a lens-shaped star system a few tens of thousands of light-years in diameter, thickened in the middle, tapered toward the rims. Later, radio will walk past dust to show arms and warps, and, later still, the halo's dark mass will be inferred from motions. But in this moment of counting, a plainer truth rises. The Milky Way is a disk, and the observer lives within it. The river in the sky becomes a roadway seen from inside its circle, bright where the traffic of stars is dense, dim where the lanes spread thin. A small, tender fact folds into the page. A careful companion at another eyepiece sweeps the sky for comets and notes nebulae that resist resolution, marking them so they do not mislead on a crowded night. Catalogs accumulate. The difference between a haze that breaks into stars and a haze that keeps its smoothness becomes a fork in the path ahead. Some mists are nearby star clusters, some are ionized clouds, some a thought that hovers just beyond consensus, are systems like ours far beyond. The notebook does not decide. It only preserves possibilities in neat lines. The night turns. Fields drift, are counted, and depart. New fields enter, are counted, and depart. The instrument, mists, is wiped and is aimed again. This is how a civilization learns the outline of its home, by adding small numbers many times and laying them on a circle. The method answers a question and preserves a mystery in the same gesture. It reveals a flattened galaxy and hides its spiral, centers the Sun and prepares to uncenter it, makes a first map and leaves blank spaces that later surveys will shade. What begins as a river becomes a cross-section, a profile, an object with axes and thickness. The act is quiet and cumulative, like sifting sand until a pattern appears or listening to rain until a roof's shape can be heard. The gauges on paper are not the galaxy, yet they are a way to live with it, to place the watcher somewhere inside a disk and say, softly, here. Lists grow where mists refuse to yield. He sweeps the eyepiece across the sky and writes down every patch that stays hazy when the stars around it sharpen. One catalog begins as a practical kindness to comet hunters, a way to mark false alarms so that drifting smudges will not be chased again. Another, larger set grows from deeper sweeps that record the sky's collection of unresolved forms. Clusters that only partly resolve, true gaseous clouds that glow, and faint spirals that sketch delicate whirlpools of light. On the page, they all share a single word, nebula, though their natures are plural and their distances unsaid. A scientific fact settles with the ink. Some of these mists are star clusters and some are genuine clouds of gas, and a few already show spiral structure under large mirrors. The big speculum reflectors, heavy, bright, and perishable, pull in enough light for arms to appear in certain objects, and the whirlpool in Cain's Venatici unfurls itself under the largest of them. Spiral forms, barred and simple, face-on and skewed, enter the lexicon by the plain act of being sketched as seen. The page grows crowded with shapes whose meaning is not yet agreed, but whose repeatable appearance is beyond doubt. A lesser-known detail lingers at the edge of the field. The great mirror that resolves the first spirals cools under the Irish air, its metal skin drinking night until dew beads on a surface the size of a room. The observing platform creaks as it pivots. Ropes and pulleys answer softly, breath fogs, and vanishes. In a nearby outbuilding, a furnace has labored to cast the mirror's alloy. Copper and tin fused and poured, a heat remembered in the glassy eyes of slag. By day, the mirror must be repolished to restore its shine. By night, it returns the favor by scraping the sky for extra light and shipping it down the tube. Uncertainty stands close and keeps its voice low. What exactly are the spirals? The distance to any one of them is unknown in this era. No parallax can be measured at such faintness, and no reliable standard candle has yet been identified within their haze. Some astronomers argue for island universes, entire star systems outside the Milky Way. Others argue that the spirals sit within the Milky Way and are nurseries or vortices of gas. The sketches themselves refuse to decide. They show a form that calls to mind storms and seashells, yet the lighting and scale carry no labels. Even the glowing clouds near home complicate the picture. Some show continuous spectra like starlight, and others, as spectroscopes come into use, display bright emission lines, a sign that true gas shines there. Soft ironies arrive and settle like dust on the tube. A list drawn to prevent confusion during comet hunts becomes one of the clearest maps to the universe's permanent confusions. The largest telescope on Earth can draw the curving arms of a spiral in crisp detail, yet cannot attach a yardstick to the picture it has made, and the mists earn the name wandering in conversation only because comets wander. The catalogued nebulae themselves do not wander at all. They hold their places so faithfully that a finder chart made in one century guides an eyepiece in the next. He turns from one haze to another, noting whether stars spark within or whether the glow keeps its softness. Planetary nebulae, a term given by their round disks, not by any relation to planets, show themselves as neat coins of light that resist full resolution, and later spectroscopy will call out their discrete green and blue lines strange, at first, and labeled nebulium, until oxygen's forbidden transitions give the lines a home. Open clusters break into points. Globular clusters smudge at the core and glitter at the rim, and their distribution will someday help to move the galaxy's center away from the sun. In this moment, the categories overlap on the page, and the act of listing becomes a quiet form of patience in the presence of ambiguity. Spiral nebulae gather as a family of their own. Some are face-on, arms loosely wound and studded with bright knots. Others tilt and cut across the field with dark lanes crossing their light. The sketches show bars and rings, bridges to companions, and title hints that will read as interaction later on. The eye notices asymmetries and keeps them. The pencil records brightness gradients with the pressure of a hand. A pattern emerges. The spirals prefer to sit away from the Milky Way's band, crowding high-latitude fields where foreground dust is thinner. The very geometry of the sky helps them be seen. A quiet analogy arrives like a small shell lifted from sand. Each spiral looks like the cross-section of a nautilus carved from faintness, with rooms that curve around a center and corridors where star formation later will be found to run. The analogy is helpful and then not. A shell grows from the inside out at a pace set by a living animal, while a galaxy's spiral arms are patterns of density waves or material arrangements shaped by gravity, rotation, and cooling gas. The eye keeps the picture anyway, as a household scale, reminder of a structure too large to visit. A gentle process becomes central. Spectroscopy. A prism or grating stretches the light into color, and the presence or absence of bright lines says whether hot gas glows on its own or whether starlight, continuous and absorbed by cooler atmospheres, is being summed. The distinction allows some nebulae to be named gas and others to be named clusters of stars. It is a narrow beam of method across a wide plane of ignorance, and it works. Still, the spirals that show arms and dust lanes keep their stubborn, mixed character. Much of their light is starlight. Many have gas. All have shape that implies motion and history. Another delicate detail folds into the margin. A sister sweeper makes parallel lists, her careful eye and small telescope adding coordinates and comments that preserve fainter objects otherwise missed. In a ledger, where many hands leave initials and brief notes, her line drawings and measured positions become stepping stones others will use. The catalogs thicken, and from them, a later compiler will assemble a new general catalog with numbers that persist, a clipped neutral language for fogs that began as surprises. Mysteries remain content to be named and not solved. If the spirals are external galaxies, how many lie beyond the reach of current glass? If they are inside the Milky Way, how do their sizes and motions fit into the disk already mapped by star? Counts? When a faint envelope seems to connect two neighbors, is it an artifact of sketching or the light of real tidal material? The questions drift in and out with the field, and the certainty is limited to the simplest thing. The shapes are really there. 3 more dry observations keep their company with the ironies. The same air that steadies a candle flame on the observing. Platform blurs the finest details of the spiral's core. Atmospheric seeing is the quiet master of how much can be believed from a single night. The soot from a lantern that warms a finger in winter leaves a patient thumbprint on a page that will someday be read as evidence of what was seen. And a catalog entry that fills a single line can stand for a structure hundreds of billions of stars wide, a compression so severe that only a ledger can bear it without complaint. He looks again. The whirlpool's arm reaches toward its small companion like a faint footpath across a meadow. A different spiral shows a dark bisecting lane, where dust cuts the light into 2 crescents. An edge-on system slices the field like a thin coin with a hairline of brightness at its rim. None of these appearances depends on the story told about them, and all of them wait for a distance that remains out of reach. The catalogs fix them to the sky with positions, sizes in arc minutes, magnitudes estimated by eye, notes on surrounding, stars. The lists do not decide what they are. They simply make it possible to return. Night advances and retires. The mists retain their names, their numbers, their patient vagueness. A fact from the page continues to be true. Some nebulae are gas, some are star clusters, and some carry spirals. A small, vivid detail from the yard continues to color the truth. Metal mirrors, lovely and temporary, must be remade in light to keep their edge. A mystery keeps its shade. Distances and natures wait for ladders not yet built. In that triad, catalogs become the memory of the sky, a way for later eyes to inherit precisely where to look, and to carry the question forward without confusion, about which smudge is which. Spirals enter the eyepiece and invite a familiar story. The arms look like eddies in a pond, like swirls of smoke, like the flattened whirl of a disk that might condense into planets around a central sun. 19th century. Minds lean toward analogy because the shapes offer it. The nebular hypothesis already circulates in lecture halls and parlors, proposing that stars and their planets arise from contracting clouds that spin and flatten, shedding rings that gather into worlds. In that climate, a spiral nebula seems, to many, a solar cradle seen from afar, a cosmic version of a process understood by symmetry, if not by measurement. A scientific fact stands quietly beside this invitation. Rotating gas and dust do flatten into disks under gravity and conservation of angular momentum, and within those disks solids aggregate, a process now traced in protoplanetary disks around infant stars and inferred in the early history of the solar system. That fact endures. What fails is the scale. A galaxy's spiral is not a single star's nursery writ large, but a stellar city's traffic pattern, a wave or arrangement that shepherds gas and star formation along grand arms, tens of thousands of light-years across. The icon resembles the process and misrepresents it at the same time. A lesser-known detail settles into the margin as a careful hand shades the arms. In the 1860s, prisms enter the telescope train in earnest, and William Huggins begins to read light as language. He points the spectroscope at the Orion Nebula and finds bright emission lines, evidence of glowing gas. He turns to several spirals and finds, instead, continuous star-like spectra, crossed by absorption, the signature of summed stars. Agnes Clerk gathers such results into lucid prose a generation later, placing spectroscopy at the center of nebular debate in a way that lets readers feel how a thin rainbow can weigh more than a thick pencil line. Under the lamp, ink and prism share custody of the question. Uncertainty keeps its even tone. If spirals wear stellar spectra, are they clusters within the Milky Way or island universes beyond it? If they partake of both stars and gas, are they vast and external or local and formative? Distances remain unmeasured, and without a ladder, scale floats. Period luminosity waits in the future. Standard candles are still lanterns with no fixed wick. The forms on paper carry features that later we'll read as dust lanes, arms of heightened star formation, bars that stir inner orbits. In this moment, they carry only the temptation to treat resemblance as identity. Soft ironies arrive, make no sound, and stay. The very law, angular momentum conserved in collapse, that correctly explains disks around baby stars becomes the lens that misreads galaxy arms as frozen whirlpools. The more faithful the sketch of a spiral's filigree, the more convincing the wrong scale appears to the eye that loves coherence. And the spectroscope that gently corrects the picture cannot supply a distance. It can tell what but not how far, leaving the mind to choose an answer and imagine a yardstick later. The nebular hypothesis keeps its place in the room. As a broad idea, it survives changing fashions, though details shift. Gravitational contraction powers stars in Kelvin and Helmholtz's hands until nuclear physics arrives. Rings that shed to form planets are challenged by later dynamics, yet the core vision of a flattening cloud persists, now seen in images of disks around T-Tauri stars and in millimeter maps where dark lanes outline material clearing or accumulating. The 19th century eye looks from that picture to the spiral and fuses them. Only later will the fusion be unmade by distance. A small craft detail leans close. Etienne Leopold Trouvelot lays pastels on dark paper in the late century, capturing nebulae and planets with soft hands. Some spirals glow in his plates like chalk shells, arms breathy and precise. The art persuades because it respects what the eye sees, and the mind that looks at the pastel accepts, for a moment, the comforts of scale-free interpretation. A drawing can be right about shape and wrong about category without ever lying. It can honor light and still leave a viewer gently misled by resemblance. Another accepted process enters with low voice. In star-forming galaxies, H2 regions bloom. Along spiral arms where density waves or material patterns compress gas, ignite massive stars, and flood nearby hydrogen with ionizing radiation that makes it glow. Those knots, visible even in 19th century sketches as brighter beads along arms, are not embryos of planets around a single star. They are nurseries for entire clusters. The picture is not mysterious in principle, but the distance that would turn arc minutes into kiloparsecs has not yet been measured, so the beads may as well be seeds to an imagination trained on the local. A gentle analogy arrives and leaves when it has done its work. A cup of tea, stirred once, shows a spiral of leaves along a shallow pattern, and the eye delights in the recognition. The analogy helps because it tames complexity into something the hand knows. It fails because tea leaves do not shine by their own light, and the fluid's friction is not a stand-in for gravity's long arithmetic. It is useful for a breath to remember the difference. A galaxy is a collection of stars and gas bound in a halo of largely unseen matter, not a brew swirling toward a drain. Mystery keeps one question soft at the edge. Even with spectra that say, stars, what sets the rhythm of the arms? Are they long-lived density waves that organize orbits, transient material features sustained by continual accretion and disturbance, or a mixture whose character varies with mass, gas fraction, and history? Modern answers exist in families and models, but they keep their qualifiers. In the 19th century, the mystery is still unnamed. The arms are simply there, and their spiral calls to minds trained on mechanics to supply a mechanism that fits. The eye. 3 more quiet observations find their chairs. A spiral's dark lane, seen in profile, suggests dust in a disk, a fact that aligns with protoplanetary insight and yet sits at an utterly different size, a staircase the 19th century cannot yet climb. A single nova in an external system looks, in that era's understanding, like a modest flare nearby. Only later will the brightness of supernova rewrite the placement of those fireworks. And the habit of putting things into one box at a time remains helpful for bookkeeping and unhelpful for galaxies, which insist on being at least 2 things at once: stars and gas, structure and history. The room with the telescope keeps to its pace. Notes accumulate: spiral, very faint; nucleus, brighter; suspected lanes. The words are careful and minimal. The inference, permitted by culture and theory, fills in the rest. The field drifts, the arm holds its curve, and the mind continues to picture planetary rings stepping inward toward worlds that wait. The sky neither confirms nor refutes the image. It merely offers photons whose colors give away composition but not dimension. Distance remains the missing axis of the diagram. It only takes a modest change of instrument to begin loosening the knot. Better prisms harden the spectral lines. Photographic plates take the place of paper and eye, gathering faintness over hours and revealing knots and lanes too low in contrast to sketch in a minute. The plates show that some spirals possess delicate, patchy arms with star-like points scattered along them. The truth presses forward gently. These are not disks of a single star's debris, but arrangements where many stars live and many more will be born, a cadence of compression and ignition written on a scale far beyond a planetary plan. Irony bows again and makes no demands. The closer a culture comes to a correct mechanism for small things, the more likely it is to misapply it to large things, a habit as natural as extrapolating a shoreline from a puddle. The more beautiful the mistaken story, the longer it enjoys. Hospitality before measurements move it on, and the better the sketches of spirals become, the more persuasive the wrongness looks, because detail is a balm for doubt. The spirals keep their arms, the spectroscope keeps its lines, the pages keep their careful phrases. A fact holds steady: rotating clouds around young stars do flatten and form planets. A poetic detail glows. Chalk dust on black paper turns into arms that feel almost wet with light. A mystery waits: what sculpts the arms and how long they last. In that triad, the 19th century rests for a while, convinced by resemblance, sheltered by absence of distance, and supported by a physics that is true in one room and untrue in another down the hall. The night accepts the misunderstanding, because the sky is patient, and time will bring a ladder. A yardstick begins with a wobble. As Earth moves around the Sun, nearby stars shift against the distant pattern by a fraction of an arcsecond, a tiny angle measured against the quiet grit of the background. Trigonometric parallax turns the planet's orbit into a baseline and simple geometry into distance, so that 1/2 of the total annual sway, expressed in arcseconds, yields a length in parsecs, a unit defined so that a parallax of 1 arcsecond sits at 1 parsec, about 3.96 light-years. The numbers are small, the consequence large. Space stops being only direction and starts being depth. A lesser-known detail rests like a glint on brass. The heliometer at Königsberg, a cut lens that splits the field so 2 images of a star can be slid past one another, lets fine angles be read by the separation needed to bring a target into coincidence with a reference. The instrument's purpose is almost domestic, a device for measuring the difference between 2 bright specks, yet the specks stand trillions of kilometers apart. A high proper motion star, 61 Cygni, is chosen not for beauty, but for its hurry. Its motion on the sky marks it as plausibly near, and near is what parallax can reach. Uncertainty gives its calm reminder. The atmosphere shivers, the lens warms and cools, the reference stars themselves have small motions. Extraction of a parallax from seasonal drift requires patience and redundancy. The first secure numbers are few, and the sphere of reliable trigonometric distance extends only to a handful of parsecs. Beyond that, the wobble dissolves into noise for the instruments of the 19th century. A ruler exists, but it is short, and the night is large. Soft ironies sit down and say nothing. A planet's small circuit, measured in minutes and meters, becomes the ruler for a universe that pretends to ignore the planet entirely. A fixed star, so named for its steady presence in the same patterns, earns its distance precisely by refusing to stay put. And the first trustworthy three-dimensional map of the local sky is drawn, not by flying outward, but by standing still and noticing that stillness is a disguise. Parallax anchors the near. The latter needs higher rungs. In a quiet room, thousands of kilometers away, plates of the small Magellanic Cloud and its cousin, the Large, are examined for stars whose brightness rises and falls with steady rhythm. The cloud's advantage is simple. Its stars are all essentially at the same great distance, so their relative differences in brightness can be read as intrinsic differences rather than perspective. Among these variables, a subset shows a tight relation. The longer the period, the brighter the star at its peak. The handwriting that records this fact is neat and undramatic. The fact is not. Period becomes luminosity. Time becomes light. A clock becomes a candle. A scientific process settles into place. The period-luminosity relation for classical Cepheid variables turns pulsation into power. Measure the times between peaks, read a luminosity from the relation, compare that. Intrinsic brightness with the observed brightness, and the distance falls out, corrected for the dimming effects of dust. Standard candle is the term adopted, a metaphor that is useful and misleading at once. The candle is not standard by nature. It is made standard by calibration. A lesser-known, almost domestic detail remains near the plates. The variables on those early photographs are marked with tiny ink symbols and listed with small care, and in winters the darkroom's safe light gives the emulsion a low red glow that feels warmer than the room is. Names are assigned from constellations or coordinates. Periods are measured by eye, point by point, on paper curves of brightness against time. The work is repetitive, and the repetition is the point. A law is coaxed from scatter by insisting that the rhythm is real. Mystery keeps one corner of the room. What is the physical mechanism behind the pulsation? Later, the key mechanism will be invoked. The opacity of partially ionized helium rises with compression, traps heat, and then releases it, establishing a self-excited cycle. But in the first noticing of the period-luminosity relation, the cause is not yet formalized. The star swells and shrinks because its envelope's physics allows it. The curve of brightness holds its beat. The inner arithmetic remains a quiet question that theory will answer after practice has made long use of the rhythm. 3 more dry observations join the ironies. To tame distance, astronomy must embrace stars that refuse to keep a single brightness. Variability, an inconvenience for most measurements, becomes the very feature that steadies the yardstick. A relation born in one small galaxy will be carried across space to measure others, even though metallicity, the fraction of elements heavier than helium, nudges the 0 point. Standardization requires acknowledging that the standard changes with composition, and dust, which hides and reddens, must be measured from colors to be undone. Extinction corrections enter as quiet bookkeeping that multiplies insight with uncertainty. Calibration is the hinge. Parallax fixes distances to the closest Cepheids in the Milky Way. Those distances set the absolute scale of the period luminosity, relation. That scale then reaches to spirals and beyond, where individual Cepheids can be resolved. Each step depends on the one below. Errors in the bottom plank ripple outward. The ladder is not a metaphor only. It is a literal sequence of dependencies, where one knob turned a little changes the placement of a galaxy by millions of light years. The process is sound and also provisional, strengthened by cross-checks and always awaiting better anchors. A gentle analogy visits. The method resembles laying stepping stones across a wide, shallow river at night. The first stones are felt by hand at the near bank, then each subsequent stone is placed where the reach of an arm, and then a pole, can touch it. None of the far stones is found directly from the bank. Each is found because the last was firm. Period is the reach, parallax is the near bank, extinction corrections are the pole that tests a dark, cold current. A small, precise fact adds its weight. Not all Cepheids are the same. Classical, Type 1. Cepheids live in young, metal-richer populations and are brighter at a given period than Type 2Q2 Cepheids, which belong to older, metal-poorer populations such as the halo and globular. Clusters. Confusing the two shifts distances and, with them, scales for whole structures. The sky supplies subtle categories. Measurement depends on respecting them. Uncertainty does not depart. It refines. The slope and zero point of the period-luminosity relation vary slightly with wavelength. Observing in the near-infrared reduces the bite of dust and tightens the scatter, yet introduces the need for precise transformations between systems. Blending in crowded distant fields biases Cepheids brighter. Careful image subtraction and high-resolution instruments help but cannot make crowding go away. Even with modern parallaxes that reach deeper into the disk of the Milky Way, small systematics survive. The ladder climbs, its joints creak softly. It holds. Ironies find new places to rest. A star that swells and shrinks becomes the most reliable thing in a distant galaxy, while the seemingly steady stars around it are useless for distance because their steadiness tells nothing about power. The brightest candles for intermediate. Ranges are too bright to exist nearby in any number, so their calibration rides on a small sample whose nearness is a cosmic accident. And a method invented to leave the solar neighborhood is, at each revision, brought back to the neighborhood. For repair. The far depends on the near as surely as the near once depended on the far for orientation. A lesser-known historical thread threads the page. The unit parsec, defined by the angle of parallax rather than by a human measure, is coined to keep numbers tidy, and with it, a new family of convenience grows. Kiloparsecs for the span. Across the Milky Way's disk, megaparsecs for the distances to other galaxies, gigaparsecs for surveys that net the large-scale web. The words themselves become quiet tools, keeping the file names of distance in a system that steps up by threes. The mechanism inside the Cepheid keeps time with dignity. As the star's outer layers compress, helium in partial ionization zones traps heat by becoming more opaque. Pressure builds, expansion follows. Ionization fronts retreat. Opacity drops. Energy escapes. Contraction resumes. The cycle is not a metronome driven from outside, but a resonance sustained by the star's own thermodynamics. Line widths and colors support the story. Radial velocity curves mirror light curves with measured offsets. Sphericity is not perfect, but the regularity survives long observing seasons and changes in instrumentation. A candle with a heartbeat becomes a rule. The ladder, with parallax on the first rungs and Cepheids above, learns to reach to supernovae of type Ia and to relations that tie galaxy rotation or velocity dispersion to luminosity, but those steps belong to later segments of the climb. For now, a fact, a detail, a mystery, and a few ironies are enough to mark where the misunderstanding begins to loosen. Distance is no longer guesswork carried by analogy. It is number carried by rhythm. The sky does not change because the ruler improves. The mind changes, and with it, the map that will soon be ready to place spirals where they belong. Two ways of seeing share a quiet room. Papers are read, lantern slides click forward, and a careful debate unfolds about what the spiral mists truly are and how large the Milky Way might be. One line of thought places everything inside a single, vast stellar system, with the Sun well away from its center. Another line proposes that the spirals are island universes, galaxies in their own right, strewn far beyond the Milky Way's rim. The arguments move without heat, each leaning on yardsticks that have only lately learned to stand. A scientific fact lies steady at the table. Globular clusters clump in a great halo whose center points toward Sagittarius, not the Sun, and variable stars within those clusters, primarily RR Lyrae, kin to Cepheids but less luminous, provide distances that lift the solar system away from the imagined center. The Milky Way is not a sphere with us in the middle. It is a system with a core distinct from our position. Star counts and cluster. Placements agree on this decentering, even if their absolute scales still carry shadows from dust and calibration. A lesser-known detail keeps to the margins like a pencil note. In the years around the debate, a patient observer measures slight internal motions in spiral nebulae on photographic plates taken years apart and concludes the spirals rotate so quickly that, if they were truly far away, their edges would exceed the speed of light. The conclusion is neat. The measurements are not. Tiny plate distortions and systematic errors masquerade as motion, and the false rotation lends comfort to the view that spirals are nearby. The mistake is honest and durable for a time, an artifact of emulsion and geometry that becomes a quiet participant in the room. Uncertainty sits between the chairs with the ease of a familiar guest. Dust behaves badly in the arithmetic of distance. Its reddening and dimming are real, but the corrections are still soft-edged. Standard candles are reliable in families, but families have branches, type 1 versus type 2s. Cepheids, RR Lyrae with their lower luminosities, novae whose intrinsic brightness varies, and the branches overlap in ways that change conclusions by tens of %. The spirals novae look faint if they are far and bright if they are near, and the ledger of counts can be read either way if dust is allowed to speak in different volumes. 3. Soft ironies take their places without announcing themselves. A method perfected to decenter the Sun within the Milky Way becomes a reason, for some, to keep all spirals at home. The map that moves us off-center is used to keep everything else inside the fence. A beautiful error about internal spiral rotation looks more persuasive the longer it survives because time adds solemnity to thin evidence. And the very corrective that would have helped, a mature understanding of interstellar extinction, evolves just slowly enough to let both sides proceed with confidence. Slowly, another evidence accrues in the background like dew. Spectra of spirals carry large recessional shifts, measured with care at a quiet telescope where the same stars that guide navigation on Earth lend anchorage to lines of calcium and hydrogen. The velocities are not decisive on their own. A thing can move fast and still be near. But as a pattern they are odd if spirals are drifting clouds within one system, and natural if they are cities in a larger geography, each participating in motions not controlled by the Milky Way's gravity. The numbers file themselves away to be used when a rung high enough to measure distances appears. A small, grounded detail inhabits the scene. Chalk dust from a diagram of period luminosity lingers on a sleeve. A brass pointer leaves a faint squeak against the glass of a display case holding a photographic plate. The room has the good dryness of winter air. Notes smell faintly of varnish. In such spaces, the scale of the universe changes by degrees, nudged by careful handwriting and the rhythm of light curves crossed against dates. The mystery that keeps the debate open is almost grammatical. What is a galaxy as a word and as a thing when half the evidence fits both sentences? A spiral can be a nursery within a larger disk, and it can be a whole disk seen from afar. Without a calibrated candle inside the haze, the syntax does not force a single reading. The night is patient with ambiguity. The sky allows two stories to occupy the same room so long as neither claims to be exclusive. A gentle analogy visits and does not overstay. Two cartographers stand inside a forest. One marks a single enormous wood with a clearing off-center. The other marks many forests separated by meadows. Both walk among trunks, count rings, and note moss. Without a high hill to climb, their maps can both be correct to the eye and wrong to the ground. The hill, in this case, will be a variable. Star beating in a distant spiral, its rhythm turning time into light and light into distance. More quiet observations find their places. Novae, counted in spirals, seem too numerous and faint if those spirals are near, yet they seem about right if the spirals are far. A ledger line that changes sign when the assumed distance changes. The distribution of globular clusters points, a finger toward a galactic center far from the Sun, yet the size of that Milky Way remains elastic until dust is fully admitted, so the same gesture can be read as all is within or much is without. And the comfort of a single, enormous Milky Way appeals to the taste for unity, while the appeal of many galaxies satisfies a taste for plurality. Both flavors are calm and neither decides the meal. The debate's tempo is not combative, but cumulative. Calibration of the period, luminosity relation inches forward. Parallaxes scratch their way deeper. Photographic plates grow smoother, faster, more predictable. Working definitions hold. A nebula remains a basket that contains gas clouds, star clusters, and spirals alike. A standard candle remains a candle whose wick is trimmed differently in different rooms. Distance remains a quantity achieved by triangulation across methods rather than given by any single device. The language is precise and provisional, a lexicon that knows it will be revised. A small, illuminating detail from practice adds itself to the ledger. In the globular cluster system, horizontal branch stars cluster around a fairly uniform absolute. Magnitude, and their presence in many clusters offers a secondary rung, rough but widespread. They are not as bright as Cepheids, not as showy as supernovae, but their sameness across clusters whispers of distance in a voice that carries farther than parallax and quieter than novae. In this way, a plain line across a color magnitude. Diagram becomes a traveler's measure. Irony bows again, still modest. The most decisive future observation in the debate, a single variable star inside a spiral, will be unremarkable to the unaided eye and decisive to the mind. The years spent refining arguments from novae counts and internal motions will be superseded in a night by a period measured against a calendar. And the notion that the Milky Way might be the whole sky will become quaint just as the Milky Way itself becomes more complex than either side expected, with a bar, a warp, and a halo of unseen matter no one at the table has yet named. The room grows quiet the way rooms do when everyone present understands that the question has nearly found its instrument. The facts on the table remain. Clusters collect toward Sagittarius. Some spirals appear to rotate on plates that are untrustworthy at the margin. Dust dims and reddens without apology. Novae come and go with an uneven brightness that complicates their use as standards. The mystery remains, what the spirals are and how far away they live. The ironies remain. The tools that help can mislead, and the errors that mislead can teach where the tools must be improved. Outside, the Milky Way lifts and sets like a weather band, indifferent to outcomes, its dark lane steady, its glow quiet. Inside, pencils are set down, lenses are capped, and a period waits to be counted in a distant patch of haze. The universe. keeps its scale while minds reach for it, and in the gap between what is and what is learned, a few calm years make space for a discovery that will nudge the spirals into their proper distance and let the debate collapse gently into a larger quiet. On a mountain above a sleeping city, a mirror gathers the quiet of Andromeda. The 100-inch Hooker reflector drinks photons on cold plates hour after hour, while the dome turns so slowly it could be mistaken for stillness. In the emulsion, a grainy oval takes shape, the great spiral, tilted and weakly barred, dust lanes, threaded across its light. Nights return and plates accumulate, and among the faint points that prickle the haze, a small star brightens and fades with a steady patience. The mark made beside it on glass is simple and almost private, VAR. A variable star in a distant spiral speaks in periods, and the period is a yardstick. A scientific fact settles with the penciled note. Classical Cepheid variables obey a period luminosity relation. The longer the beat, the greater the intrinsic brightness. Measure the rhythm, infer the power, compare to the observed light, correct for dust, read the distance. The arithmetic is spare and decisive. Applied to this star, and then to others that follow in the same galaxy, the answer refuses to fit inside the Milky Way. Andromeda is not a cloud in our disk. It is a stellar system of its own, beyond the rim, so far that the space between becomes part of the thought. A lesser-known detail stays close to the plate itself. The glass bears layer upon layer of fine annotations, tick marks, crosshairs, a date, and the variable's locations on successive nights are circled with a faint graphite sheen that catches lamplight like frost. Beyond the oval, a darker knot sits where observers 4 decades earlier recorded a nova, S Andromedae of 1885, bright enough to be seen in small telescopes and now understood as a supernova whose flare briefly outshone the galaxy's core. The emulsion is a palimpsest of decisions: past surprise, present rhythm, future distance. Uncertainty keeps a small chair near the desk. Cephids come in populations. Metallicity shifts their 0 point. Crowding biases their measured brightness. Dust reddens and dims unevenly across the spiral's face. Even today, the exact distance to Andromeda is refined and re-refined by eclipsing binaries, tip of the red giant branch stars, water massers, and near-infrared Cepheid calibrations, a set of cross-checks that keep the value within a narrow cordon, and keep curiosity alive. The margin is not a failure. It is the place where instruments talk to one another. 3. Soft ironies sit down in turn. The least steady star in the field, the one that refuses a single brightness, becomes the most dependable ruler for a galaxy. A penciled exclamation on a fragile plate changes the size of the known universe more than any speech could manage. And the nebulae, first listed to prevent comet hunters from chasing false wanderers, now deliver a permanent address for island universes. Not here, but out there, at scales that turn the Milky Way into local weather. The Hooker mirror hums with night air. Temperature drifts, the dome breathes, the tracking clock sends a mild, mechanical heartbeat into the floor. Exposure after exposure, the faint beat of a remote star is taken down like dictation. The period is days, the amplitude modest, the regularity patient. Using the relation drawn from a Magellanic neighbor and anchored as well as the era allows, a distance on the order of 1,000,000 light-years tumbles out, far beyond any plausible diameter for a single galaxy universe. The nebular debate yields, not by force, but by a scale that removes the question from grammar. A gentle analogy pauses by the eyepiece and leaves no footprints. In thick fog along a dark coast, a solitary lighthouse marks its range by the timing of its flash. Count the seconds, and the shoreline draws back or steps forward in the mind. The Cepheid is that lamp, but the sea is a black vacuum, and the shore is not a cliff but a city of hundreds of billions of suns. The metaphor helps for a breath, and then the galaxy demands its own language again. A detail of method glows faintly. Heliocentric corrections nudge observation times. Plate defects are chased and set aside. Comparison stars define local 0 points. Light curves are traced with pencil on thin paper held against a window or lamp. The work is almost domestic, in its gestures and remote in its consequence. Periods are refined, second variables are found. The scatter on the relation tightens slightly, then slightly again. The discipline is quiet repetition. The reward is a number that does not blink. There is mystery still at the edges of the oval. What pattern keeps Andromeda's arms graceful? Long-lived density waves shepherding gas into star formation, transient material structures stirred by past encounters, or a mixture that breathes over time? How exactly its dark halo distributes its invisible mass, how its satellite galaxies pluck at its outskirts, how its bar funnels gas toward the nucleus. These are questions that continue to accept new answers as new instruments open new bands. Even its sideways motion through the local group, measured now in micro-arcseconds per year, carries uncertainties that complicate predictions by a quiet 500 million years. 3 more dry observations find their places. A century of careful arguments about novae counts and plate-measured rotations collapse into a few digits beside a light curve. Debate ends not in a crescendo, but in a ledger. The distance that moves spirals beyond the Milky Way also halves, and then doubles in later recalibrations, as population differences among Cepheids and better 0 points arrive. A reminder that being right about category can coexist with being approximate about scale. And the galaxy that seems monolithic from a city backyard resolves, under deeper scrutiny, into parts. Thin disk, thick disk, bar, halo, streams, so that certainty expands in one dimension while complexity expands in another. The shift in naming is almost unspoken. Spiral nebulae recede and galaxies take their place, and with the change the word universe grows elastic. The Milky Way keeps its river's curve across the summer. Andromeda keeps its faint oval. The difference is that space between is recognized as space, not as a darkness within one system. The sky does not need to change to become larger. The mind only needs a scale that will not yield under weight. Elsewhere on the mountain, plates of other spirals receive the same treatment. Variables are flagged. VAR echoes along the margins. Distances extend into a quiet constellation of numbers. Some systems prove too far for Cepheids in that era. Later, type Ia supernovae will take the handoff, and still later, scaling relations will help, and then redshift itself will graduate from mere velocity to a measure tied to expansion. But in this moment, a single class of star repeats a syllable across galaxies. Period, luminosity, distance. A small companion fact finds a seat. The Cepheids, bright enough to anchor external galaxies, are rare nearby. Their calibration rides, on careful parallax to a handful in the Milky Way, and on cluster membership where distances are known by independent means. The chain holds because many links are inspected often. The mountain's work travels down the slope as numbers. The slope's city spreads brighter each year. The brightness below erases dim stars, and the mirror above answers by integrating faintness longer. The long exposure becomes a way to reclaim dark from light. Irony returns once more, as soft as breath. The spiral's dust lanes, which first hid stars and misled counts, now help by revealing a disk's tilt and structure, aiding corrections the earlier era could not make. The same Andromeda that was once sketched as a possible local whirlpool becomes, at its true distance, the nearest large laboratory for the physics of spiral galaxies, a neighbor whose intimacy is defined not by proximity alone, but by the ease with which its parts can be resolved. And the notebook that once carried guesses now carries calibrations, A habit of careful margins has outlived the questions that filled them. The plates are sleeved and filed. A fact holds. A Cephid in Andromeda has been resolved, its period measured, its luminosity inferred, its distance read beyond the Milky Way's edge. A small tactile detail persists. The graphite ring around a star on glass, the human trace that turns a distant heartbeat into a number. A mystery lingers. The full choreography of arms, bars, halos, and time inside that oval. Between them, misunderstanding gives way not to finality, but to a wider quiet, where the word galaxy settles with the weight of a commonplace, and the night resumes, unchanged and larger. A diagram takes on the shape of sound. Chalk lines on a blackboard branch into a tidy tuning fork. Along the handle, round ellipticals labeled E0 to E7. At the split, lenticulars, S0, holding the hinge. Along one tine, unbarred spirals saw through C. Arms loosening as bulges shrink. Along the other, barred spirals SBA through SBC. The bar laid like a quiet beam through the nucleus. The drawing is simple, almost domestic in its geometry, and it proposes families rather than a story. A map of looks, a taxonomy of light's distribution, a calm order imposed on a sky that refuses to speak in one voice. A scientifically accepted fact stands in soft relief beside the lines. Morphology correlates with stellar content and gas. Elliptical galaxies, with smooth light that often follows a de Vaucouleurs profile, brightness falling roughly as the 1/4 power of radius, tend to be red, old, and gas-poor. Spirals with disks that carry arms patterned by density and dust are bluer, gas-rich, and alive with H2 regions. Lenticulars sit between, disks without much gas or arm structure, their star formation quieted. The diagram is not only shape, it hints at history through color and chemistry, a spectrum of behaviors written as silhouettes. A lesser-known detail glints like chalk dust on a cuff. In the neat letters beside the ovals, the elliptical's subtypes come from flattening measured, as an integer index tied to axis ratio, a code for how stretched an ellipse appears on the plate. The A0 itself arrives later than the earliest sketch, a careful bridge added to acknowledge galaxies that are unmistakably disky, yet tired of making stars. On the photographic table nearby, bars often hide in blue images but emerge in the near-infrared. The same galaxy shifts its accent when seen through different windows, as if the fork's tines move slightly with wavelength and leave a faint smear of chalk where the classification was too firm. Uncertainty sits down with good. Posture. The origin of these families, the reason the sky separates into red sequence and blue cloud with a quiet green valley between, remains a layered story. Major mergers can scramble disks into spheroids. Minor mergers can thicken without erasing. Internal feedback can quench without violence. Environment can strip gas and still leave the disk, producing lenticulars that look like spirals with the music turned down. Bars form, dissolve, and form again in simulations, stirring gas inward to feed a nucleus or starburst and then fading, as fuel is spent. Which pathways dominate when and why some halos host bars while others resist remain present tense questions with answers that arrive in plural. 3 soft ironies lean against the chalk tray. A sequence that suggests evolution is carefully introduced as a snapshot, yet the word invites time into a picture that means to avoid it. A classification drawn from smooth photographs becomes a proxy for the physics beneath, even though the physics can diverge wildly while leaving the same surface shape. And the fork, so neat that it comforts, must grow a web of subscript letters and hybrid types, SAB, SD, ES0, as soon as it meets the sky in quantity, a reminder that categories multiply when tidy lines touch statistics. The diagrams. families expand into behaviors. Early type spirals, SBA, carry large bulges and tight, faint arms. Late types, SBC, show open arms and small bulges, their discs laced with dust lanes and star-forming knots. Ellipticals divide in kinematics as well as shape, with many proving to be fast rotators hiding faint discs, and a minority remaining slow, rounder, supported more by velocity dispersion than by spin. The fork can be redrawn with arrows in velocity, space, and the letters can be annotated with numbers from integral field spectroscopy. Yet the chalk figure remains useful because the eye still begins with light before it listens to motion. A gentle analogy visits and keeps its voice low. The tuning fork is like a herbarium pressed inside a book, leaves arranged by outline and vein, each specimen tidy in its paper frame. Later, one learns that the same shape can spring from different soils, that drought and shade write similar edges on unrelated plants, and that a pressed leaf betrays little of the wind that moved it. The analogy helps for a moment, then recedes. A galaxy is not a leaf, and the wind is gravity, gas, and time, all of which leave deeper marks than paper can hold. The morphology-density relation breathes through the diagram like a slow tide. In crowded clusters, ellipticals and S-zeros dominate. In quieter fields, spirals keep their arms. Ram pressure stripping and harassment in clusters heat and remove gas from infalling disks. Starvation halts inflow and star formation fades. Interactions disturb or erase. The fork, pinned to a poster at a meeting, carries an invisible gradient. As the environment thickens, the tines tilt toward quenched forms. The science is steady. The outlines, when seen against a map of neighbors, take on the color of context. A small, tactile detail remains near the plates. On deep images, a faint ripple of light sometimes encircles a lenticular. A shell or wave, debris from a past minor merger that never reached the surface of the classification. On others, a bar's ends touch the head of a ring, a resonance. Pattern small enough to miss in a brief look and clear as a bell on a longer stare. The fork has no glyph for these whispers. The chalk cannot carry every note. Mystery lingers along the bar. Why is the bar fraction in the nearby universe high, and how does it evolve with time? Are bars more likely to appear as disks cool and grow more massive, or as halos spin more slowly, or as tidal encounters nudge orbits just so? Observations suggest trends. Simulations propose mechanisms. Yet the clean switch that turns a bar on and leaves it lit remains a composite of many dimmer switches. In the same quiet, lenticulars ask their own question, mostly quenched spirals, or a more varied lineage where some disks are born quiet under different assembly histories. More dry observations settle, content to be ordinary. A galaxy can migrate across the fork without moving in space, simply by shutting down its star formation and smoothing its arms. The change is in behavior, not address. A pure de vos couleurs. Law fits some ellipticals less well than a Cirsic profile with index free to float. The simplicity of R1-4 yields in many cases to an index that adjusts to history. And the wavelength one chooses to look through reshapes the census. In blue, light, dust, and young stars dominate the look. In the near-infrared, the old skeleton of the stellar mass steps forward and bars flourish. The fork is adopted, adapted, and revised. De vos couleurs will extend it into a numerical classification. Later, atlases will embroider rings, lenses, and variety along the tines. Digital surveys will flood the desk with millions of examples. Volunteers will click through images to lend human pattern recognition to the statistics of shape. Yet the chalk drawing persists on lecture walls because it is mnemonic and gentle. A grammar of galaxies that lets the mind hold many at once without the noise of difference overwhelming the common forms. Irony makes one more quiet bow. The earliest. Sketch, drawn in an era when the universe has just learned to be larger, becomes the icon that endures even after it is known to be incomplete. The very act of classifying by appearance, a choice made because spectra and motions are harder to gather in quantity, turns out to reflect genuine couplings among mass, angular momentum, and gas supply more faithfully than its simplicity would suggest. And a diagram meant to sort becomes, in time, a question mark in disguise. Why this distribution of shapes at all? The board erases easily. The sky does not. The fork remains in the air after the chalk is gone, guiding eyes across. Plates and screens. A fact remains. Families of galaxies sort by appearance in ways that correspond on average to content and context. A small, lightly smudged detail persists. Bars reveal themselves more clearly in the red where old stars glow, and the same system can slide from one letter to another as wavelengths change. A mystery stays seated. The proportion of types, their drift with epoch, and the precise routes between letters remain an ensemble of histories rather than a single path. The night, indifferent, carries on presenting each galaxy whole, while the diagram translates wholes into shapes and invites the mind to listen for order there, like a tuning fork that hums even after the finger leaves it. Dust writes absence across light. In photographs and by eye, dark lanes rake through spiral disks and cut the Milky Way's band into broken ribbons, as if the galaxy forgets itself in places. The forgetting is chemical and small. Grains a fraction of a micron wide, silicates, carbonaceous solids, ices where conditions permit, intercept starlight and scatter blue photons more than red. Extinction and reddening enter the lexicon as if weather had learned spectroscopy. Stars behind a veil appear dimmer and redder than their kin beside a clear window, and early star counts, faithful to what they saw, undercounted where the veil was thick. A scientifically accepted relation steadies the correction. The color excess EBV, the difference between observed and intrinsic color, links to total extinction through a parameter RV that floats with environment. Near 3.1 in diffuse interstellar medium, often higher in dense clouds where grains have grown. An empirical law ties wavelength to loss. The curve bends in the ultraviolet, rises toward the blue, softens in the red. Correcting a single field becomes housekeeping. Measure colors, choose an RV, subtract the dust's arithmetic, and let true luminosities step forward. Whole sky surveys turn that housekeeping into cartography, and the galaxy's map sharpens, where the veil is known. A lesser-known detail glows at short wavelengths. Near 2175 angstroms, many sightlines show a broad bump in the extinction curve, a resonance that hints at certain carbon structures, perhaps small graphitic sheets or aromatic molecules. The feature varies from place to place. In some neighboring galaxies it weakens. In some galactic lines of sight it sharpens. The bump is a fingerprint that is not yet a name. It rides above the general slope like a small wave on a long swell, a specific reminder that dust is a plural word. Uncertainty keeps its calm chair. What, exactly, are the major carriers of the diffuse interstellar bands? The hundreds of narrow absorption features that lace reddened starlight? A portion of the pattern now sits with ionized fullerenes. Much of it remains unsigned. How grains align with magnetic fields, radiative torques, paramagnetic relaxation, both, and in which proportions, continues to be refined by polarization maps. How rapidly dust is grown in the cold ISM after being forged in stellar winds and supernovae, and how rapidly it is shredded by shocks, sets budgets that simulations balance but still adjust. In the details of carbon's arrangements and silicate lattices, questions keep their half-light. Soft ironies arrive and take their places. The same grains that hide starbirth make starbirth possible, letting clouds cool by radiating in the infrared, until gravity can finish its gathering. The very dust that dims a galaxy in visible light re-radiates that energy in the far infrared, making the galaxy bright again at wavelengths the eye cannot see. And the invisible fibers of magnetic field that grains reveal by aligning, visible only because the grains polarize starlight, become tracers drawn by the very particles that obstruct the view. Infrared and radio widen the room. At 21 centimeters, neutral hydrogen whispers a hyperfine line that walks past dust without noticing. The Milky Way's disk and the disks of other galaxies open like maps, warped edges and outer arms traced in a frequency that slides through soot. Carbon monoxide, bright at millimeter wavelengths, marks the denser molecular clouds where stars form. Conversion factors turn its glow into H2 column densities. Near-infrared light, with interstellar extinction a tenth of the visibles, lets the barred bulge behind our galaxy's midplane step outward in star counts, a structure guessed at, in kinematics becoming visible as a long, slanted brightness. The remedy for dust is not to wish it away, but to change the window. A quiet analogy comes and goes. Dust lanes in a spiral are like banks along a slow, shallow river. The darkest edges show where material piles up, and along those edges, new settlements, the H2 regions, string themselves like towns. The analogy holds only so far. A river cuts by erosion. A spiral arm keeps its pattern by gravity and motion. Still, the sense of flow held by boundaries helps a watcher see that absence is not emptiness, but contour. Another detail lights at high latitude. Infrared satellites find a faint filamentary glow even far from the Milky Way's band. Cirrus, made of cold dust in the galactic halo and thick disk, ripples of emission too tenuous to notice in visible light. On deep images, these wisps can masquerade as tidal streams from merging galaxies. In catalogs, they are flagged with caution, so one faint thing is not mistaken for another. The sky's background is textured. Even away from the plane, dust keeps a low voice. Mystery returns at the largest scales. How exactly the Milky Way's spiral pattern runs, how many long arms, where they fork, how the warp lifts and dips with azimuth, still changes slightly with each new survey and tracer. Young stars, masers in star-forming regions, CO clouds, neutral hydrogen, and dust extinction all sketch arms, and the sketches do not align perfectly. The bar's length and angle continue to be tuned as infrared star counts and kinematics improve. The picture converges, but it does not freeze. A living system resists being turned into a single drawing. 3 more dry observations settle beside the numbers. A galaxy's total energy budget can be divided into starlight and dust light, and for some systems, half or more emerges in the infrared, a fact that makes visible a poor name for most of what is. The reddening that tricks color magnitude. Diagrams into aging a population can be partly unraveled by combining bands and listening to polarization, yet partly is all it offers. The remainder is a margin the eye must respect. And the earliest maps that misplace the sun at the galaxy's center did not err from carelessness, but from faith in transparency. A faith that dust patiently revised. Polarization adds its tracer's thread. Starlight filtered by aligned. Grains emerges with its electric field leaning in a preferred direction. Thermal dust emission, too, is polarized, each vector a small arrow on the map of the magnetic field. Surveys sew these arrows into quilts that wrap the sky, fields draping, over arms bending around clouds, threading the diffuse medium with quiet coherence. The geometry is not decoration. It steers charged particles, guides flows, and resists collapse where it can. The same dust that darkens a lane draws a line through invisibles. Grains cycle through the galaxy as leaves through seasons. They condense. In outflows from aging stars, cross the cold medium gathering mantles, grow by accreting atoms and colliding gently, are shattered by shocks, sputtered in hot gas, rebuilt where chemistry allows. A budget emerges. To maintain the observed mass in dust, growth in the interstellar medium must be efficient. Stellar sources alone cannot keep up. This arithmetic is not a romance. It is a spreadsheet with inputs, losses, and rates that teach how often the galaxy must heal its own opacity. Irony bows again and stays mild. The most precise corrections for dust come from places least bothered by it: high, dry deserts and space, while the densest clouds that need the correction most also starve the photons needed to measure it. The best maps of the Milky Way's plane arrive in wavelengths that never reach the ground, and the most familiar visual photographs of grand spirals are those most altered by the very grains that power their beauty. And an absence drawn by dust becomes an object of study so complete that the absence now has catalogs, temperatures, emissivities, and indices as if it were a presence. The night keeps its balance. Dust dims, reddens, and redirects. Infrared and radio restore, reweight, and reveal. A fact holds. Interstellar grains veil starlight and shape what can be seen, and their effects can be measured and, in part, undone. A small, precise detail quietly glints. A bump near 2175 angstroms rises in many sightlines like a gentle signature of carbon. A mystery remains: the full roster of molecules and solids that write absorption into reddened light, and the exact blend of mechanisms that align those grains to draw the field. Behind the lanes, hidden disks and bars stay intact, waiting in wavelengths where the veil thins, and the maps expand one band at a time until the missing places become rooms that can be entered without apology. A curve stays flat where it should fall. In galaxies across the sky, emission from hydrogen in the outer disk, Ha in the red for stars and ionized gas, and the 21-centimeter whisper for neutral clouds, shifts by the Doppler effect, one side blue, the other red, as the disk turns. Plot circular speed against radius and the line refuses to descend. Instead of Kepler's decline, the rotation curve rises and then settles into a near-constant plateau far beyond the bright starry disk. The implication is plain and steady. Mass continues where light does not. Around and through each galaxy extends an unseen halo, whose gravity keeps the outer parts circling faster than starlight alone can justify. A lesser-known detail glows in the dim room where the spectra are taken. An image tube intensifier hums, with faint blue-green light, lifting weak lines above the grain of photographic emulsion. Later, CCDs will take over with quieter efficiency. The long slit is aligned along a galaxy's major axis, and the sodium lamps of a distant town scratch narrow lines into the night unless a filter trims them away. Sky OH emission breathes in the background, a lace of faint lines that must be subtracted carefully so that what remains is only the galaxy's own voice. On the bench, a microdensitometer scrolls a thin trace of darkness turned into numbers. The curve that emerges looks almost indifferent to its consequence. Uncertainty keeps its slow counsel. The nature of the unseen mass remains open, cold, slow-moving. Particles that hardly interact with light. Axion-like quanta whose wave nature softens small structures. Sterile neutrinos that sit at the edge of known particle families. Or, in a different key, a modification of gravity's law at low accelerations. Each option carries predictions that meet some data and miss others. Core cusp tensions in dwarf galaxies, satellite counts around Milky Way analogs, lensing, maps in clusters, and the smoothness of the early universe microwave background. Simulations improve, feedback from supernovae and black holes puffs and shapes baryons, and small-scale troubles blur at the edges. Yet the identity of the halo remains a quiet question. Soft ironies take their seats along the plot. To learn the most about a galaxy, one listens where the galaxy is faintest, The outskirts draw the loudest conclusions. The grand revelation hides in the most unromantic shape, a line that refuses to dip, a flatness that points to depth, and the invisible becomes the best studied component. Its properties are assembled entirely from the behavior of what can be seen, a portrait sketched by the tilt of spectral lines and the arcs of distorted background galaxies. Clusters of galaxies add their own arithmetic. Velocities of member galaxies in the coma and others spread wide. Virial theorems turn that spread into total mass, and the inferred mass dwarfs what the summed starlight would suggest. Hot intracluster. Gas, bright in X-rays, contributes a large share yet still leaves much unaccounted for. Gravitational lensing, weak statistical shears across many background sources and strong clean arcs around some cluster cores, maps the mass directly. In projection, the contours of lensing align best with the hypothesis that most of the matter neither shines nor collides the way gas does. A bullet-like merger of two clusters separates the hot X-ray gas from the lensing peaks. Galaxies and dark halos sail through while gas stalls, a quiet diagram in the sky of interaction versus indifference. A gentle analogy visits and then leaves. Imagine a festival of paper lanterns drifting along an invisible river at night. The lights mark the flow, but the water carries them. Watching their speeds at different distances from the center reveals the shape of the stream that itself cannot be seen. The analogy is helpful until it is not. A galaxy's halo is not moving as a current, and the orbiting lanterns are stars and clouds bound by a potential that changes only slowly with time. Still, the sense of a hidden framework guiding bright tracers remains useful for a breath. The accepted process sits quietly in the middle of the room. Gravity bends paths and sets speeds. If mass were limited to what shines and glows in the visible, and near infrared, outer rotation curves would fall roughly as 1 over the square root of radius. They do not. If cluster mass were only stars and gas, galaxy velocities would be narrower and lensed arcs fewer. They are not. Across methods, rotation, dispersion, lensing, the inference converges. Most mass neither emits nor absorbs light in significant quantity. In galaxies, it gathers into halos whose density falls with radius in profiles that simulations of cold, collisionless matter produce in family forms. A smaller, tactile fact holds a thread. In dwarf spheroidal companions of the Milky Way, faint ellipses of stars barely bound. Individual stellar velocities, measured one by one with high-resolution spectra, carry dispersions that imply mass-to-light ratios of tens to hundreds. The night's most transparent little systems, pruned of gas and dust, speak softly and still point to halos that outweigh their starlight by wide margins. A handful of red giant spectra, their calcium triplet lines slightly widened by random motion, become the quietest evidence of all. Mystery keeps its share of the page. At the centers of small galaxies, do halos rise like cusps or flatten into cores? Feedback that pushes gas out and lets it fall back can heat and redistribute dark matter, carving soft centers where pure simulations predict sharp ones. Observations differ from case to case. Do subhalos predicted in large numbers all host tiny galaxies, or do many remain dark, present only in lensing and dynamics? Surveys extend to fainter satellites each year, finding more, yet the census stays incomplete. Even the interaction strength among dark particles themselves remains bounded by mergers and shapes, but is not yet nailed strict. 3 more dry observations stand beside the ledger. The smooth flatness of rotation curves hides the chaotic lives of gas and stars, whose individual orbits and feedback are tangled. The curve works because gravity sums indifference out of detail. The same halo that holds a disk steady also protects delicate spiral patterns from winding too fast, a paradox in appearance, The keeper of calm is a sea of motionless, invisible matter. And the value of a galaxy's mass-to-light ratio depends on wavelength as much as on mass. Measure in blue, measure in red, measure in infrared, and the light in the ratio changes while the mass does not. A reminder that the denominator is mood and the numerator is law. Data from early times bind the present to the past. The faint ripples called baryon acoustic oscillations, preserved in the spacing of galaxies across vast surveys, and the nearly Gaussian texture of the cosmic. Microwave background together favor a universe where dark matter makes structure early and guides baryons into it. The large filaments and voids of the present-day Webb match calculations that start with a cold, collisionless component and let gravity work for billions of years. The halos seen around galaxies today extend far beyond their disks, joining those, filaments like dewdrops beating along unseen threads. A subtle craft detail returns to the spectrograph. Measuring rotation where light is thin means leaning on gas. Ha when star formation is present, N2 and S2 lines when ionization favors them, and especially the 21-centimeter line where dust is thick or star formation is quiet. The slit must be placed across the longest apparent axis. The inclination must be known to turn projected speeds into true ones. The distance must be judged to place the curve on a radius scale. Beam, smearing, asymmetric drift, and pressure support are each corrected in turn. The flatness survives the adjustments, a plateau that resists being eroded by method. Irony nods again. The pursuit of luminous galaxies turns into a census of darkness. Survey time for pretty spirals ends up measuring the invisible scaffolding beneath them. Direct detection experiments on Earth, designed to sense a passing dark particle, become exercises in exquisite silence, where the most informative result for years is a limit rather than a signal, and the largest component of a galaxy's mass. Profile, the part students might expect to draw last, is drawn first in calculations, because without it, the rest will not stay put. The night absorbs conclusions without changing color. A fact holds. Rotation curves, cluster dynamics, and lensing point to massive, extended halos of matter that does not shine. A small instrument detail persists. An image tube's soft glow, or a CCD's quiet well, magnifies faint spectral lines so that speed can be heard in light. A mystery remains. What the halo is made of, how it behaves on the smallest scales, and whether gravity itself requires an amendment in regimes of low acceleration. Between them, the curve that should fall stays flat. The outskirts speak louder. Then the core, and galaxies continue to turn inside envelopes that refuse to be seen except by the paths they force. Some galaxies keep a small sun at their center that outshines them all. A compact engine, no bigger than a solar system and sometimes smaller, floods the spectrum with power as gas falls inward, heats in a thin disk, and releases gravitational energy with an efficiency stars cannot match. The nucleus glows in ultraviolet, and X-ray light pours infrared from warm dust and in some cases launches narrow jets that walk far beyond the host, carving radio lobes in the thin outskirts. Quasar, Seyfert, radio galaxy. Blazar. The names are variations on a single fact. At many galactic cores live supermassive black holes, and when they feed, their accretion turns mass into light and motion into weather. Lines in the spectrum sort, the light into rooms. Close to the engine, gas orbits fast and broad emission lines spill across hundreds or thousands of kilometers per second. Farther out, thinner clouds respond with narrow lines set by a gentler field. Orientation and obscuration thread the view. A dusty molecular torus hides or reveals the broadline region depending on angle. Infrared light from that same dust re-radiates the engine's heat. Unification is the quiet word. One architecture seen in different projections and stages explains many disparate names. Reverberation mapping listens to time itself. Light from the continuum flickers, and, days to weeks later, line-emitting gas echoes, its delay turning into a distance, its width into a velocity, the two together into a black hole mass that agrees. With other measures in systems where stars or misers can be weighed, a lesser-known precise detail turns like a ring in the dark. In a handful of nuclei, water molecules in sub-parsec disks around the central mass act as cosmic masers, amplifying microwave light into bright, narrow lines. Their Doppler shifts sketch a perfect Keplerian rotation, red on one side, blue on the other, with systemic spikes from gas moving across our line of sight. In NGC 4258 and cousins, these maser spots trace a warp and yield a geometric distance, while the rotation curve within light years of the core gives a clean black hole mass. The instrument is radio. The tool interferometry measured in thousands of kilometers, and the effect is almost household in description. A laser pointer in the microwave, yet it writes sub-parsec orbits from galaxies millions of light-years away. Feedback extends the engine's influence outward like a breath that never quite stops. Radiation pressure on dust, line-driven winds from the disk, and magnetically powered jets each coupled to gas and stars at different radii. In quasar mode, luminous outflows push on cold clouds, shock the warm medium, and sometimes sweep star-forming gas from galactic centers. In radio mode, jets inflate bubbles in hot atmospheres, their PV work visible as cavities in X-ray maps of cluster cores, preventing overcooling and holding star formation quiet for long seasons. The coupling is not magic. It is momentum and energy-finding purchase in a multi-phase medium. Outflow velocities of hundreds to thousands of kilometers per second, molecular gas entrained with ionized filaments, and ripples in cluster gas all speak to the same exchange, a tiny center negotiating with a huge circumference. Mystery keeps its seat near the controls. What sets the switch between radio loud and radio quiet lives? Black hole spin, magnetic flux threading the horizon, host halo mass, or histories of cold versus hot accretion. How exactly jets, collimated, near the hole by fields and rotation, hand their energy to clouds that are clumpy and cool without simply drilling past? Why do some nuclei change look within years? Changing look, AGN that shed or grow broad lines, and how much of that theater is obscuration moving and how much is the accretion rate itself flickering? Even the coevolution etched into the MS relation, where black hole mass scales with the stellar velocity dispersion of a bulge, holds its causal arrow lightly. Does feedback enforce the correlation? Or does assembly history write it in parallel? Across many mergers and flows, three soft ironies drift to the edge of the desk and stay. The darkest objects in theory become the brightest beacons in practice. Their event horizons surrounded by light so fierce that they mark the distant sky like small, steady dawns. A region measured in light hours changes the climate of a galaxy. Measured in tens of kiloparsecs, a heart whose pulse organizes a body 1,000,000 times larger. And to weigh something that permits no light to leave, observers do not look for it. They time the responses of what surrounds it, delays, echoes, and orbits, learning presence by the choreography of everything else. Accepted processes settle into a quiet sequence. Viscous torques in the accretion disk move angular momentum, outward letting mass slide in. Near the hole, general relativity shapes the innermost stable circular orbit and sets a ceiling on how close matter can orbit before plunging. The Eddington limit balances radiation pressure against gravity for ionized gas. Many quasars linger near that limit, their growth timed by duty cycles that light and then dim across cosmic epochs. The quasar luminosity function rises toward redshift 2 and ebbs toward the present, a history that mirrors the star formation rate density. Both peak when the universe is a few billion years old, both decline as gas supplies thin and halos heat. A gentle analogy visits for a moment. The nucleus is a city's power plant seen from far away at night, a compact facility whose steam and hum are invisible but whose lights mark the skyline. When demand is high, more stacks glow and trains of cars deliver fuel. When demand drops, the glow ebbs but the structure remains, ready to surge again. The analogy holds only faintly. A real plant emits by combustion. An accretion flow shines by gravitational release, yet the sense of a small hub shaping a wide grid has its small hues. A quieter detail lingers at low surface brightness. Above and below the Milky Way's plane, two giant lobes of gamma-ray emission swell like twin lanterns, relics perhaps of past activity from the central engine or of starburst winds. X-ray and microwave maps outline them with different textures. Closer in, thin fingers of ionized gas trace ionization cones in some Seyferts, narrow beams of permitted photons lighting dust like theater gels. In another galaxy's outer darkness, a greenish cloud, a light echo of a nucleus that has since dimmed, holds the spectral memory of a brighter time. The engine flickers on human timescales after all. The sky keeps the minutes in gas. Uncertainty does not trouble the central proof. Supermassive black holes sit in the cores of massive galaxies. Their existence is traced by stellar orbits that speed and twist, by gas that whirlpools and fluoresces, by images that outline a shadow where light bends and fails. What remains open are the fine controls. How seeds form at the start. From the deaths of the first stars or the direct collapse of pristine clouds, and how often the seeds meet and merge, how feedback seeds quenching without ending disks where disks persist, how the multi-scale traffic of cold streams, bars, rings, and inflows keeps fuel reaching a place that needs it small and steady. 3 more dry observations keep time with the instruments. The most luminous phases are brief compared to the age of a galaxy, so most black holes spend most of their lives dim. Archaeology in starlight and gas must reconstruct the rare bright hours from common faint days. The same radiation that can lift and heat gas can also, at gentler levels or at edges of outflows, compress clouds and seed star formation, negative and positive feedback leaning on the same medium with different hands. And the cavities that jets inflate in cluster cores look empty in X-rays, yet they are full of work. Their rims ripple, their bow waves travel, and their energy budgets match the cooling they must offset if a brightest cluster galaxy is to remain quiet. Close in, the physics keeps its simple center. Gravity dominates, light redshifts, and time dilates. Far out, the consequences keep their complex perimeter. Disks slowed or starved, halos warmed, metallicities shifted, colors moved from blue to red by a process with no color at all. A fact remains: accretion onto supermassive black holes powers active galactic nuclei and, through winds and jets, shapes the gas that would otherwise make stars. A small, vivid detail persists. Water molecules near one horizon act as lighthouses in the radio, tiny beacons that mark a black hole's grip with exquisite arcs. A mystery stays, the precise switches and couplings that turn an invisible boundary into a galaxy-scale regulator. In that poise between engine and envelope, misunderstanding continues to thin. The quiet core keeps its hum. The larger disk keeps its turning. Gravity draws out thread and ribbon when galaxies pass. Disks that once keep tidy spirals grow bridges and tails. Faint starlight unspooled by tidal forces that stretch orbits into narrow arcs. Close approaches tug stars and gas outward while flinging some inward. Angular momentum moves from one radius to another, and the system changes shape even when no star collides with another. The encounter is slow in human terms and swift in orbital ones. A few 100 million years from first touch to aftermath, long enough for gas to be shocked into clumps and for young clusters to flower along newly drawn curves of light. Tidal. Tails sweep like handwriting. Shells ripple around spheroids like the wake of a boat that has already passed. A scientifically accepted process steadies the image. Dynamical friction robs orbiting companions of energy and angular momentum as they stir wakes in the larger galaxy's stars and dark matter. Together, the pair spiral inward. In a major merger where masses are comparable, disks heat and often lose their ordered rotation, relaxing into spheroids through violent relaxation. In minor mergers, a large disk thickens, bars grow or are renewed, and outer halos receive streams as the small companion sheds stars. Gas funneled inward by torques crowds the center, ignites starbursts, feeds a nucleus, or both. The signatures are visible: bridges between pairs, antennae-like tails, warped outer disks, and later, relaxed ellipticals with boxy or disky isophotes that remember how the orbits were mixed. A lesser-known detail glows faintly at low surface brightness. In the late 20th century, photographic amplification and unsharp masking on deep plates revealed delicate shells around otherwise smooth galaxies. Concentric ripples, interleaved arcs, phase-wrapped debris from swallowed companions on near-radial orbits. The technique, perfected in quiet darkrooms, amplifies light the eye would pass over. The shells are timekeepers, spacing themselves by the period of oscillation in the remnant's potential. In others, extremely long digital exposures in modern surveys uncover tidal dwarfs, small, gas-rich knots that condense in the far ends of tidal tails, self-gravitating and often deficient in dark matter because they form from the outer, baryon-dominated disks, not from halos. The outskirts keep a diary even when the center has forgotten. Mystery keeps company at several scales. How often do disks truly die in major mergers, and how often do they regrow from fresh, high angular momentum gas supplied by filaments or captured companions? At high redshift, where gas fractions are large, simulations and observations show disk regrowth is common. Near the present, with leaner reservoirs, the outcomes skew differently. What sets the fate of a bar born or renewed in an encounter? Does it persist for a Hubble time or fade as gas is exhausted and orbits scatter? And in the delicate math of angular momentum exchange, what precise balances among halo spin, orbit geometry, and gas fraction decide whether the remnant is a fast-rotating elliptical, a quenched lenticular, or a disk that merely wears scars? Soft ironies arrive and sit without interrupting anything. A non-collision, stars missing stars by light years, leaves the clearest scars of impact, as if emptiness hits harder than contact. Encounters that fling matter outward to the edge of a system also drive matter inward to fuel central activity. So the same tide that makes a tail prints a bright core, and the grandest arcs in a galaxy's portrait, drawn in the faintest light, tell the most about its history. The bold disk says now, the dim stream says before. Encounters paint anatomy. The antennae-like pairs, with two long tails curving away and a bridge between, are textbook examples of near-prograde passages where disks spin with the orbit and tides efficiently draw out material. The mice-like systems show asymmetry where masses disagree or orbits differ. Edge-on pairs lift warps and corrugations. Retrograde encounters leave stubbier features and heat without long tails. In massive clusters, high-speed drive-by interactions, harassment, roughened disks, and trim gas without binding pairs. Ram pressure from hot intracluster gas peels cold gas from infalling spirals, leaving star formation to fade while the stellar disk keeps its shape. Environment modulates the choreography. The same law, gravity, plays many tempos. A gentle analogy lingers and then lets go. Two whirlpools in a shallow tidal flat approach. Their rims pull threads of foam from one. Another, and where the eddies meet, water rushes inward toward a quiet, deep point. The eye follows the filaments across the surface and forgets that the true exchange happens below, in the currents. The image helps for a breath, then yields. A galaxy is not fluid, yet its many stars respond so collectively that the pattern might as well be a tide. Streams keep a second record in halos. Around the Milky Way, faint rivers of stars, the Sagittarius stream looping widely, the GD1 filament, the Orphan arcing, thread the sky. Their positions and velocities map the shape of the dark halo and its lumps. Gaps along them betray past brushings by subhalos too dim to see. In an external disk, a polar ring, a small galaxy's gas reoriented into a plane at right angles to the host holds a fossil of angular momentum transfer. Its long-term stability speaks to the halo's shape. The outer parts are not any afterthought. They are the laboratory where gravity's scaffolding is weighed. Dry observations join the list with no need for emphasis. The most luminous infrared galaxies in the nearby universe often wear merger signatures. Buried starbursts and dust-enshrouded nuclei turning gravitational compression into far infrared glow. The star clusters that stud tidal arms, blue and compact. Today will age into globular-like systems. Some will fall back, some will remain as independent traces long after the tail itself disperses. And the orbits of supermassive black holes from merging galaxies take their own slow spiral inward under dynamical friction and then gravitational wave emission, a long courtship likely ending in a coalescence that the surrounding stars barely notice while space-time itself rings. A small, precise craft detail looks over a shoulder in the control room. To capture the faintest tails, observers dither images, stack them with careful sky subtraction, and build flat fields from night sky frames that average out stars because dome flats cannot erase gradients at the level required. Reflections. In the optics masquerade as false shells. Scattered light from bright stars far outside the field paints subtle ghosts. The honest features persist across rotations of the camera and telescope, across filters, across nights. The illusions do not. Low surface brightness demands skepticism as much as it demands depth. Uncertainty sits again near the ledger. How much of an elliptical's boxy or disky isophotes come from the memory of the last major merger versus the accumulation of many smaller ones? Do most lenticulars result from gentle quenching of spirals in groups and clusters, or from gas-poor mergers that leave a disk but rob it of fuel? The answers vary with mass and environment. Even in well-studied pairs, the fraction of gas that turns into stars versus the fraction ejected into the halo or beyond balances on feedback whose details, supernova timing, coupling efficiencies, cosmic rays, remain under refinement. 3. More ironies keep a quiet smile. A galaxy's most elegant spirals, stretched in tails that tempt a painter, arise from the most disorderly act in its life. Mergers that promise to erase disks sometimes seed the conditions for new ones, as fresh. Gas with high angular momentum cools and lays down a thin structure atop the old. And the cleanest dynamical inferences about halos come not from tranquil galaxies, but from ones untidy with streams, bridges, and shells. Disorder clarifies the underlying order. Accepted processes flow underneath. During the first pericenter, passage, bars, and oval distortions grow and torque gas. During coalescence, central gas densities peak. Feedback sprays and puffs the interstellar medium. The heated stars settle into a new equilibrium. In phase space, orbits mix. In real space, light smooths. The Tumri sequence, a visual progression from early interaction to merging remnant, becomes a classroom shorthand for a path that many systems follow and many deviate from. A scaffold for understanding that is useful because it is illustrative, not because it is exclusive. A small, evocative detail remains out in the tails. H2 regions sparkle along the farthest reaches, powered by hot, short-lived stars that will die while their birthplaces evaporate into the halo. Their nebular lines carry the metallicity of their parent disks, often higher than dwarf galaxies of similar mass, a chemical clue that these knots are recycled, not primordial. In this way, even a bead of light at the end of a faint ribbon tells where it comes from. The night absorbs each pass and keeps turning. A fact remains. Interacting galaxies raise tidal features, drive gas inward, build spheroids, thicken disks, and write their past in streams and shells that can be read with patient light. A lesser-known detail persists. Some small galaxies condense in the tails themselves and carry enriched gas but little dark matter, fossils of an encounter rather than of a halo. A mystery stays near the center, how the balance of gas fraction, orbit, and halo shape decides whether a disk dies, reforms, or persists. Between them, the sky's slow collisions draw tides in stars, and the long arithmetic of orbits turns encounter into memory. A map of everything begins with a number called Z. On the spectra of faint galaxies, familiar lines, hydrogens, Balmer series, calcium's H and K, oxygen's doublets, drift to longer wavelengths. The shift is not a quirk of the atom, but of space. Expansion stretches light while it travels, so redshift becomes a measure of distance when coupled to a cosmology. One after another, points find their place. Not only right ascension and declination, but also depth. When the points are plotted, the sky stops being a shell and becomes a volume, and in that volume a pattern emerges that is hard to unsee once seen. Threads and sheets, knots and hollows, a foam of galaxies with room between. Scientifically accepted process hums beneath the picture. Tiny fluctuations in the early universe, ripples written as microkelvin variations in the cosmic microwave background, grow under gravity. Where the density is slightly higher, matter gathers faster. Where lower, it drifts away. Cold, nearly. Collisionless dark matter collapses first into filaments and halos. Gas falls in, cools, and makes stars where conditions allow. Over billions of years, the web sharpens, voids empty, walls weld, and clusters thicken at the nodes. The largest features stretch for hundreds of millions of light-years, yet their origin is a quiet arithmetic. Linear growth swelling into non-linearity, power at long wavelengths feeding structure that is both delicate and immense. A lesser-known, hands-on detail lingers in the dome where the survey begins. On the focal plane, thousands of small robots the size of coins nudge optical fibers into precise positions, each aiming for a single galaxy on the sky. The petals of the instrument open. Fibers sip starlight from a winter-cold night and send it down to spectrographs that arrange color into order. Before fibers, plates of aluminum were drilled with holes for each target. Pins held small prisms that fed light into bundles. Both systems keep the same promise: to turn a sky of scattered smudges into a ledger of distances. Between exposures, the field rotator ticks softly, and the robots shuffle again, a quiet choreography that lays thread after thread across the universe. Uncertainty sits with the plot and keeps it honest. Converting redshift to distance demands a cosmological model. The expansion rate and matter content set the curve that turns Z into length. Peculiar velocities, the additional motions of galaxies within clusters and along filaments, stretch and squeeze features along the line of sight, producing fingers of God, where clusters smear radially and gentle squashing where large-scale infall compresses patterns. Bias, the way galaxies sample the underlying dark matter, varies with type and time, so the luminous web is not a perfect tracer of the invisible skeleton. And while baryon acoustic oscillations set a standard ruler in the pattern, 8A, broad preference for pairs of galaxies separated by about 150 megaparsecs, co-moving, a fossil of early universe sound, measuring that ruler to exquisite precision still rests on calibrations that shift slightly as surveys grow and instruments change. Soft ironies drift like fine dust and settle without complaint. The largest structures are mapped by counting the smallest marks. Single spectra that, taken alone, say little, but in the sum build a geometry of everything. The emptiest regions, the voids, teach the most about what fills the universe because their yawning simplicity leaves fewer places for ambiguity to hide. And the third coordinate, depth, arrives not from seeing farther, but from listening to how quickly far things flee. Speed becomes space by way of a law that began as a local relation and matured into the modern expansion. Slices of the web take on familiar names. An early wedge diagram shows a great wall, a sheet of galaxies so extended across the slice that the pencil plot looks like it has hit a horizon. In another direction, the Buddha's void yawns, a near-spherical underdensity so large that a handful of isolated galaxies inside it feel like lanterns left in an empty field. Later, deeper maps reveal that no wall is entire, no void absolute. Everything connects in 3 dimensions and features that dominate. A slice soften when rotated in the mind. The filamentary network is not a stack of pancakes but a tangle of strands, braided in places, knotted in others, dissolving into halos where clusters live. A gentle analogy visits, stays a moment, and leaves. Morning. Frost on a window grows, in branching patterns that wander and meet. Between the rhymes lie clear panes where nothing has taken hold. The web looks like that when projected, a leaf of ice laid over a dark field. The analogy serves only briefly. Frost grows from the edge inward in minutes. The cosmic web grows everywhere at once over eons, guided by gravity rather than capillaries, of water. Still, the feeling of a network that selects where to be dense and where to be spare helps the eye relax around the pattern. The accepted method becomes its own weather. Redshift space distortions imprint 2 signatures. On small scales, random motions in clusters smear them into radial spikes. On larger scales, coherent infall toward overdense regions squashes the pattern along the line of sight, the Kaiser effect, a subtle flattening that can be measured statistically. Each effect encodes a rate of growth for structure, a way to test gravity on scales far beyond any laboratory. Cross-correlations with weak lensing, the minute shearing of background galaxy shapes by intervening mass, stitch light and dark together, checking whether galaxies sit where mass says they should. In the averages, the answers agree. Écrit. Cold, dark matter skeleton under a dark energy expansion, both inferred by many roads. Another craft detail leans from the workbench. To draw the web, spectra must be scrubbed of night sky emission, a comb of OH lines that rises and falls with temperature and time. Software learns to follow that comb. Fibers learn to share information. Standard stars drift through each field, to pin down throughput and adjustment. On the wall, a poster shows the target tiling, overlapping circular fields that patch the sky without holes. It looks like a quilt. Each patch is both small and cosmically large, a few degrees wide, and a swath of space billions of light-years deep. Mystery keeps a careful edge. Why do the faintest dwarf galaxies tuck themselves so tightly to the brightest halos? And how do the most isolated void galaxies grow thin disks with such patience? What precise blend of astrophysical processes, supernova feedback, photoionization, cold streams, magnetic fields, cosmic rays, determines which filaments shine boldly in star formation and which stay skeletal and dim? Even on the grandest scales, small tensions stir. The exact amplitude of matter clustering inferred from galaxy-weak lensing surveys versus that from the microwave background differs slightly in some analyses. A quiet discrepancy that invites more data and gentler assumptions. The claims are measured in sigmas that do not raise a voice. The curiosity persists. 3 more dry observations join the others. A void is not truly empty. It holds thin filaments, dwarf halos, and the occasional upright disk that keeps its rotation in a quiet neighborhood where nothing presses. A wall is not a wall in any strong sense. It is a fold in the density field, transient when viewed on. Deterringly long timescales caught in the act of becoming something else while the language pretends to permanence. And the very standard ruler that tightens cosmology, the acoustic scale's crest preserved in pair counts, is broad, not sharp. Its strength lies not in a line on a page, but in a bump in a statistic that emerges only when millions of pairs have been compared. The web acquires dynamics in the mind. Galaxies stream along filaments toward nodes. Gas, heated as it falls, cools in dense places where it can. Shocks run along walls. Turbulence stirs in cluster outskirts. Magnetic fields drape and stretch. Relic radio arcs light up as fossil electrons. Find fresh acceleration. The pattern is not static. It is a moment in a flow that looks still only because the frame is measured in billions of years. Along a very long line of sight, the same filament can carry many epochs. An early blue population at one distance, a later redder population downstream in time. The map is a timescape as much as a landscape, a small tactile detail in habits. The plotting room. The first time a wedge diagram prints correctly, a curl of paper hangs from the plotter like a thin slice of bark. The ink dries into a forest of dots tilting outward. Later, screens take over, and the slice spins like a fan, still carrying the same surprise. The sky's smudges are not random. They arrange themselves along routes one can trace with a finger. Somewhere on a shelf, the old aluminum plug plates lie stacked like symbols, each with a pattern of holes that once coupled the dome to the deep. Irony bows once more and stays mild. The universe's largest pattern, set by gravity's patient. Rule is revealed with the help of chemistry and night air, as atoms act as signposts and the atmosphere either cooperates or does not. The very emptiness that first appeared as lack turns precise, with volumes, densities, and even void galaxies, catalogued like rare birds. And maps that look like finished quilts are draft work forever. Every new survey adds a strip of fabric at the edge or refines a seam in the middle, and the pattern holds while the stitches improve. A fact remains. Redshift surveys turn sky into space and reveal a cosmic web of filaments, walls, and voids grown from small initial ripples amplified by gravity. A quiet, lesser-known detail persists. Thousands of little fiber robots crawl a focal plane each clear night, placing slender mouths above faint smudges so that depth can be drunk in sips. A mystery stays. How precisely the light we see traces. The dark matter we do not. How the web's statistics test gravity and growth, and why small tensions endure between different lenses on the same universe. Between them, the map widens, the threads hold, the hollows deepen, and the night accepts being made three-dimensional without any need to move. Hydrogen whispers in a single, stubborn note. Deep in the radio, at a rest frequency near 1420 megahertz, a wavelength of about 21 centimeters, a hyperfine transition flips the relative spins of a proton and its electron. The probability is low, the spontaneous lifetime long, but the universe stocks this atom in such numbers that the improbable becomes inevitable. Galaxies speak in this line whether or not they are making stars. Because interstellar hydrogen is mostly neutral in wide outskirts and thin layers, and because radio waves ignore dust, the 21-centimeter emission turns the invisible into a map. A scientifically accepted process takes over once the dish is pointed. The Doppler effect shifts. The line by the speed of the gas along the line of sight. Frequency becomes velocity. Observers fill a cube with brightness temperature as a function of right ascension, declination, and velocity, and from that cube they unfold rotation curves, warp angles, and streams. In the Milky Way, tangent points along each inner sightline. Let rotation be read from the brightest ridge in velocity. In other galaxies, long slits and synthesis maps trace both sides of the disk, red and blue. The great surprise, repeated, is that disks stay gassy far beyond their bright starlight, flaring and warping in outer parts like shallow plates set on warm air. A lesser-known, delicate detail inscribes itself in profiles as a narrow bite. Against, a warmer background of hydrogen at the same velocity. Colder foreground clouds draw HI self-absorption, a negative notch that marks gas so cool, tens of kelvins, that it dims the line rather than brightening it. The notch is a shadow cast in radio by the cold neutral medium hiding inside the warmer neutral medium, a quiet silhouette where chemistry is slow and turbulence small. In the same family, hydrogen seen in absorption against a compact radio continuum. Source turns the interstellar medium into a filter. A pencil beam measurement yields spin temperatures and column densities with a precision that emission alone cannot. Uncertainty sits gently at the edges of these maps. Why are outer disks so commonly warped? A gentle S-shape when seen in profile. And what combination of misaligned infall, satellite torques, or halo triaxiality sets the tilt and keeps it precessing without damping away? How much of the high-velocity cloud population above the Milky Way's plane comes from a galactic fountain of gas lifted by supernovae and falling back, and how much rains in from the circumgalactic medium or is stripped from satellites like the Magellanic Clouds? Even the thickness and flaring of HI layers, which rise with radius, encode thermal and turbulent pressures that models match in outline and still adjust in detail. Soft ironies find their places without remark. The universe's quietest atomic. Transition, so improbable that a single atom could wait millions of years to radiate, becomes the loudest cartographer of galactic structure. The line most untouched by dust, and so most honest about what is there, is the one most easily drowned by human noise. Radio frequency interference sits like weather on a clear night, and gas that does not shine to the eye tells us where light will later be made, sketching the scaffolding for stars in a wavelength that a pupil can never see. Arrays and single dishes split the labor. Interferometers, rows and rings of antennas phase together, sharpen vision and draw spirals, holes and bars in neutral hydrogen with angular precision. Single dishes, enormous and patient, hear. The broader, fainter see and take quick drift scans that net thousands of galaxies by their line alone. In crowded clusters, the maps show ram pressure stripping at work. A spiral's HI disk truncated, its tail bent back by hot intracluster, wind. Star formation fades where fuel is peeled away. In fields and groups, the same maps turn up bridges and streams, the Magellanic Stream trailing behind our neighboring dwarfs in a ribbon of hydrogen that wraps a great arc around the sky. A gentle analogy visits and recedes. The 21-centimeter line is a stethoscope held to a galaxy's chest. Each frequency a depth, each velocity a valve, each profile a heartbeat that reveals chambers, leaks, and murmurs. The image helps for a moment and then yields. A body pumps, a disk turns, and gravity sets the rhythm without muscles. The accepted picture of phases settles nearby. Neutral hydrogen inhabits two main thermal states in pressure balance: a cold neutral medium at roughly 50-100 K and a warm neutral medium near 6,000-10,000 K, with turbulence and magnetic fields mediating their coexistence. Supernovae carve H, eye holes and supershells that grow, merge, and sometimes blow out of thin disks as chimneys, venting energy into a thick layer where gas returns in arcs and filaments. In the outskirts, where gravity and pressure are low, H thickens and warps, storing angular momentum and marking the edge where ionization from the metagalactic background thins neutral gas into a skin. A small, terrestrial detail clings to the control room. Near one observatory, a posted sign asks visitors to switch off phones and microwaves. A radio quiet zone extends for miles around, and trucks that once raised interference with faulty ignition systems have been politely repaired. The Protected. Band around 1420 MHz buys peace, but harmonics and electronics leak. On some nights the sky's spectrum hums with thin artificial combs. On others it settles, and the line comes through like breath in a sleeping house. Mystery steps farther back, in time, and lowers its voice. Long before galaxies burn bright, neutral hydrogen fills the universe between the first stars, and its 21-centimeter line redshifts into meter-long wavelengths by the time it reaches Earth. Experiments spread dipoles across deserts and tundra, building instruments that seek a global dip in the sky's radio brightness from the cosmic dawn, when the first sources couple the hydrogen spin temperature to the cooling gas. Foregrounds 1,000 times brighter, the Milky Way's synchrotron hum, the hiss of unresolved sources, must be modeled to a whisper. Reflections in cables can mimic the sought-for curve. Upper limits on the fluctuating signal have tightened. One claimed deep absorption feature remains debated. The exact timing and shape of reionization's radio signature continue to sharpen without quite arriving. The promise remains a cartography of the fog, a way to watch the first structures light the dark. 3 more dry observations tread softly. A warp can be invisible in stars and glaring in hydrogen, so the plainest disk in blue light hides a bent outer ocean in radio. The longest baselines of an interferometer bring the finest detail, yet they filter out the very extended, low-surface brightness, a mission that single dishes hear easily. No one instrument hears the whole story. And the same Doppler shifts that lift velocities from frequency also braid the near and the far along a line of sight in the inner Milky Way, making distance assignments a kinematic puzzle with 2 answers, unless tangent geometry or absorption breaks the tie. Technique accumulates like dew. Bandpass calibration divides away the instrument's own ripples. Frequency switching or position switching cancels slow drifts. Radio recombination lines from ionized gas are flagged to keep them from masquerading as hydrogen. In synthesis images, deconvolution pulls a clean sky from a dirty beam, masks protect faint structures from being eaten by algorithms, cubes are sliced and integrated into moment maps that show total column, mean velocity, and dispersion. Faint. Streams appear that look like scratches at first and become highways when integrated along the right velocity field. High-velocity clouds trace the halo's weather. Some show metallicities akin to the outer disk, hinting at fountain rain. Others carry the chemical accent of the Magellanic System. A few are so low in metals that they likely hold in falling circumgalactic gas. Their distances are measured by bracketing absorption in spectra of stars at known ranges. Their shapes billow with the ram pressure of a hot corona that, until recently, was only inferred and is now imaged in X-rays. The halo is not dry. It breathes, and HI is the condensation on that breath. Irony bows again, unhurried. The outermost. Gas that hardly makes stars tomorrow decides how many stars can be made next year, and yet it is the part most often cropped from pretty pictures. A transition identified in quantum mechanics textbooks for its quaintness becomes the practical clockwork of galaxy kinematics, and the local human effort to keep radio quiet, a switch flipped, a rotor silenced, becomes the enabling act for listening to hydrogen from a time before cities existed. A fact remains, the 21-centimeter hyperfine transition of neutral. Hydrogen maps warped disks, extended outskirts, streams, and halos through dust, turning frequency into velocity and velocity into structure. A lesser-known detail persists. HI self-absorption writes cool clouds as negative notches against warmer emission, a radio shadow that pins down temperatures and phases. A mystery stays open, the origin and persistence of warps, the balance of fountain and infall in high-velocity clouds and the first faint radio glow of cosmic dawn that instruments chase across quiet lands. Between them, a single, patient line threads galaxies together like a seam you can feel more than see. And the night, which looks silent, reveals it has been singing under the noise all along. Cold becomes luminous when the wavelength is long enough. Dust grains that smother ultraviolet light from young stars warm by a few tens of kelvins and re-radiate that energy in the infrared and sub-millimeter, their spectra rising like smooth hills beyond the red. A galaxy busy with hidden star formation glows where eyes do not, at 24, 70, 100, 160 micrometers and onward into the millimeter, the energy of absorbed starlight returning as a broad thermal hump. A simple, accepted physics sits under the glow. Grains emit like modified blackbodies with emissivity that scales as a power of wavelength. Fit the hump and the slope, and temperature and dust mass follow, while energy balance ties the obscured. Ultraviolet to the infrared output and turns light into a star formation rate. Instruments learn the language of faint warmth. Space-borne observatories, cryogenic telescopes cooled by liquid helium, sunshields, and clever refrigerators, carry cameras and spectrometers that read thermal light above an atmosphere too bright and wet for most bands. On the ground, at high, dry plateaus where water vapor thins, bolometer arrays and heterodyne receivers listen through atmospheric windows at 350, 450, 850 micrometers and longer. Interferometers phase many dishes into a single sharp ear. The array writes rings, arms, and compact knots with subarc-second precision, stitching baselines into a mirror measured in kilometers. In this light, dust lanes stop being absence and become architecture. A lesser-known, tactile detail rests with the observers. The secondary mirror on a submillimeter telescope chops, nodding a few times per second to subtract the warm, flickering sky. The motion is a whisper through the dome. At altitude, a small meter traces the 225 GHz opacity of the air every minute. Values drift with wind and frost like weather on a lake. Cryostats cycle at dawn. Closed-cycle coolers thrum softly. As stages drop toward a few kelvins, vapor plumes ghost from helium vents. Fingers leave no prints on metal left to equilibrate with the night. Flux calibrations rely on planets, Mars, Uranus, steady disks whose brightness temperatures are cataloged like standards in a kitchen drawer. The science moves with steady patience. In dusty starbursts, the infrared luminosity rises to 10, or 100 billion suns worth. In ultraluminous cases, 1 trillion. Fine structure lines cool the gas. C2 at 158 micrometers, OI at 63, O3 at 88, N2 at 122 and 205. Their ratios weigh densities, temperatures, and radiation fields in photodissociation regions and H2 zones. Carbon monoxide ladders, from JC10 upward, mark molecular gas reservoirs and excitation. Combine line luminosity with a conversion factor, and total H2 mass follows. With interferometers, knots of dense gas in bars and arms resolve into beads along dust spines. With deep single-dish maps, diffuse reservoirs spread beyond the bright optical disk. The embers of a galaxy reveal where tomorrow's starlight waits. Uncertainty keeps its soft edge. Exactly which dust species set emissivity slopes in different environments, amorphous silicates, carbonaceous grains, mantled composites, remains under refinement, and the emissivity index V can slide with temperature and composition, coupling two fitted parameters that theorists prefer to pull apart. In powerful starbursts, the far infrared C2 deficit deepens as luminosity rises, and the precise blend of causes, compactness, charging of grains, high ionization parameters, or AGN dilution, resists being reduced to one knob. In the young universe, massive dusty galaxies appear early, their dust masses challenging naive budgets from supernovae and asymptotic giant branch stars. Grain growth in the interstellar medium likely carries the load, but rates and timescales remain gentle debates. Soft ironies take their chairs. The darkest dust lanes in visible images become the brightest structures when seen in the far infrared, so the places that look most empty to the eye are the most crowded with energy. Cold grains only tens of kelvins hot announce the hottest. Processes, intense star formation cloaked by its own smoke, and the most distant dusty galaxies do not fade as quickly as intuition says. A negative K correction at sub-millimeter wavelengths keeps flux roughly level with redshift across a wide range, so a bright dusty system at 10 billion light-years can look as insistent as one at 3. An accepted process threads the interpretation. Radiative transfer marries geometry and opacity, sending synthetic photons through model galaxies until their emergent spectra match the observed continuum and lines. Energy absorbed in the ultraviolet must reappear in the infrared. A solution that breaks. That accounting fails, no matter how pretty its fit to a single band. Population synthesis provides the spectral shape of young and old stars. Dust screens, clumps, and birth clouds absorb with different efficiencies. Scattering reintroduces light at odd angles. The model is a household ledger with many envelopes, incoming, outgoing, saved as heat, and when the rows add cleanly, star formation histories, dust masses, and obscured fractions emerge with uncertainties that can be spoken aloud. A gentle analogy visits for a breath. Infrared maps are like walking across winter snow at dusk with a thermal camera in hand. Footprints glow where the day's passage warmed the ground. Piles and drift lines take shape that ordinary sight missed. The analogy fits only partly. Snow melts and refreezes in hours. Dust cycles over tens of millions of years. Yet the sense that heat reveals structure invisible to daylight is allowed to linger for a moment. Another modest detail sits in the data. Polarized thermal emission from elongated grains aligned with magnetic fields traces the geometry of those fields across clouds and disks. Vectors curl about dense ridges and thread spiral arms. In some nearby galaxies, polarization maps in the submillimeter draw smooth, coherent lines across kiloparsecs, a skeleton thinner than starlight implies. In bright, clumpy starbursts, vectors tangle where turbulence wrestles with ordered flows. The same dust that hides starlight grants a view of the invisible scaffolding that shapes it. Mystery keeps a room at high redshift. Early deep fields at long wavelengths reveal compact, luminous sources where dust and heavy elements already thrive when the universe is a fraction of its present age. Some show line shifts in O through and C2 that hint at vigorous metal-enriched regions. Others look faint in the lines relative to their continuum. How quickly the first heavy elements condense onto grains, how much of the light arises from nascent active nuclei versus stars, and how the earliest dusty galaxies assemble such mass so fast remain questions that gather new answers without closing. The door. 3 more dry observations arrive quietly. A galaxy's infrared output, integrated across bands, can match or exceed its optical starlight, making visible the minority shareholder in many systems. The same fine structure line that is the dominant coolant in one environment can retreat into weakness in another. Universality is rare, calibration plural, and the submillimeter sky is confusion-limited in single-dish maps. Beams collect several faint sources at once, and interferometers must unbraid them, a reminder that sharpness, not exposure time alone, decides who is who. Technique becomes routine and remains intricate. Spectrometers step through frequency with etalons or gratings. Wideband receivers take in whole chunks of the millimeter sky at once. Atmospheric transmission is mapped by sky dips, scanning in elevation to fit air mass curves. Pointing is checked on bright quasars. Band passes are flattened with frequent calibrators. Data reduction moves cubes through pipelines. Flat fields, despiking, decorrelation of atmospheric noise, inverse variance weighting, matched filtering for point sources. On the screen, a faint blot resolves into a pair of compact knots joined by a diffuse bridge. In the ledger, one line becomes two. Fluxes halved and positions revised by an arc second. Irony bows once more. Clouds on Earth that make infrared windows close are made of the same water that these instruments chase in other galaxies as a coolant and tracer. The atmosphere hides in the same molecule it reveals. The careful accounting that turns dust light into star formation rates depends on assumptions about initial mass functions that are themselves debated. So the hidden star formation emerges with error bars that refuse to be ironed flat. And the long wavelength cameras that see through dust to find star formation are themselves wrapped in layers of insulation and aluminum foil, looking like the very objects they study. A fact remains: dust that absorbs ultraviolet and visible. Starlight re-radiates in the infrared and submillimeter, and those wavelengths, mapped by cryogenic space telescopes and high, dry arrays, reveal obscured star formation, molecular gas, and magnetic structure that optical light cannot show. A small, concrete detail persists. Chopping secondaries, opacity meters, and planet-based flux scales make these measurements domestic in their rituals, even as they reach galaxies billions of light-years away. A mystery endures. The grain physics that shapes emissivity, the origins of the C2 deficit in the most compact systems, and the rapid dust enrichment at early times. Between them, embers glow where shadows once lay, and galaxies disclose their hidden work in a light that feels less like brightness than warmth. A camera stares into a small, nearly empty patch of sky until it stops being empty. Photon by photon, the field accumulates faintness. Hours become days, and the background resolves into a thicket of distant systems whose light began when the universe is young. Deep fields are patience made visible, a stack of long exposures aligned and drizzled until red noise averages down, and even the softest smudges step forward. In the Hubble Ultra Deep Field, this practice first turns a dark postage stamp into a crowd of early galaxies. With newer instruments, the same ritual reaches farther still, transforming a narrow cone of space into a time tunnel where the youngest systems appear as red pinpricks with sharp spectral breaks. The underlying fact is plain. Expansion stretches. Light and dims surface brightness as 1 q-sis, raised to 4, yet long exposures and sensitive detectors push through that dimming to reveal what lies beyond the obvious. The process becomes method. With JWST, medium and broad near-infrared filters sift candidates by their colors. A dropout blue ward of a wavelength that shifts with redshift marks the Lyman break, and multi-object spectroscopy with microshutters checks the guess. In JADES, that sequence carries all the way to spectra. Two compact sources show an abrupt absence of flux blue ward of about 1.85 micrometers, a clean Lyman A break that places them near redshift 14, later refined with tentative metal lines, and careful modeling. The finding is both careful and calm. The first secure spectroscopic redshifts at Z14 arrive as modest discontinuities in a thin, low-signal trace, and the distances slip into the ledger. A small, tactile detail sits just behind the data. Those spectra depend on medium-band imaging as well as broad bands. Additional JADES Origins field filters narrow the color space so interlopers with Balmer breaks cannot masquerade as high-Z dropouts. Even the nearby presence of a foreground source, its own Balmer break suspiciously close to the target's putative Lyman break, is accounted for. Its lines are measured, its mild lensing is modeled, and its contamination is limited to a few percent. The microshutters that admit the faint light open like tiny doors in a grid, thousands of choices arranged at cryogenic temperature so that a handful of distant galaxies can whisper at once. Uncertainty keeps its seat at the edge of the image. Some early candidates proved to be nearer galaxies with intense emission lines stacking into filters and mimicking a high Z break. A famous photometric source first proposed around Z16 later resolves into a dusty, strong-line object at Z4.9. The lesson is not harsh, it is procedural. Selection improves with added bands. Spectroscopy sorts the rest. Meanwhile, ongoing surveys find that bright galaxies appear earlier and in greater numbers than many pre-JWST models anticipated, though the size of the surprise softens as calibrations improve and contamination is pared away. The question remains measured rather than alarming. How efficient is early star formation when gas is pristine and halos small, and how much of the initial shock is a census artifact? Soft ironies arrive and take their places without raising their voices. The darkest, most starless-looking square on the sky becomes the most crowded the longer it is watched. A discontinuity, the sudden absence of flux blueward of a line, carries more distance information than any brightness does, and the earliest galaxies to be seen can look oddly mature at first glance, while the mature understanding of how they are counted still grows up around them. Lensing lends a second, quiet boost. Clusters like Able 2744 act as natural telescopes, magnifying background sources and smearing them into arcs. Deep programs use this amplification to net fainter, earlier systems than a blank field alone can offer. The practice is patient and statistical. Lens models from multiple teams map magnification and uncertainty, and number counts are corrected for the shrinking sky behind the glass. The reward is a field where galaxies from within the first few 100 million years appear with enough light to study, and the cost is a careful accounting of distortion, a gentle analogy, visits, and leaves. Deep imaging is like listening to a pond at night until ripples become audible. In the beginning, only the loudest splashes are heard. Later, the smaller circles overlapping at the surface announce fish and wind. The analogy helps for a breath, and then yields. A detector does not hear, it counts, and the ripples here are spectral breaks that mark ionized edges in a neutral universe. The accepted physics beneath the images is simple in statement and elaborate in consequence. Expansion stretches wavelengths, thins photon arrival rates, and broadens apparent sizes so that surface brightness falls as 1p mosu costa 4. Reionization raises the neutral fraction of hydrogen such that true Lyman-A emission often cannot escape at the highest redshifts. And stellar populations in their first generations skew hot, driving blue ultraviolet slopes. The data invert those rules to learn. A sharp drop signals intergalactic absorption. A slope measures dust and age. A non-detection in just the right filters becomes a detection of youth. A lesser-known real-world detail clings to the edges of the frames. Deep fields spend much of their integration time rejecting what the sky and spacecraft add unhelpfully: scattered light, persistence from bright sources that passed across the detector minutes earlier, snowball-like cosmic ray bursts in the infrared, arrays, the soft comb of zodiacal background that rises and falls with ecliptic latitude. Dithers step the pointing by small offsets. The drizzle algorithm remaps pixels and averages down defects. The final mosaic is as much housekeeping as it is light. Mystery remains beside the facts without contradiction. Do the luminous Z10 galaxies, flagged so far, demand unusual star formation efficiencies, or will larger samples, refined completeness, and better treatment of emission line contamination fold them back into the long arc of LCDM assembly? How quickly does dust grow in the very first systems, and how does that growth alter what a deep field counts as blue and bright? even with secure spectra at Z14, the statistics are young. The slope of the ultraviolet luminosity function at the brightest end settles slowly, and small tensions between predicted and measured abundances hover in the margins where models are most sensitive. 3. More dry observations sit down and stay. The cleanest early spectra often show no strong lines at all, just a break. Yet those very quiet spectra are the ones that move the record. A single foreground neighbor, a fraction of an arc-second away, can complicate years of inference. So medium-band imaging and careful modeling become as decisive as exposure time. And cosmic variance, the luck of what lies within one narrow cone, can masquerade as a law until enough cones are gathered to average out the streaks. The field remains small. The view remains large. A fact holds. Ultra-deep imaging and spectroscopy now place secure galaxies at redshifts around 14, and lensing adds fainter, earlier sources to the census by bending the path of their light. A precise, almost household detail persists. Medium-band filters and microshutter masks are the modest tools that separate true dropouts from imposters and let a few photons write a redshift. A mystery stays open. Whether the first bright population is truly ahead of schedule or only appears. So because our first looks favor the rare and the magnified, in that poise, photons keep arriving. The tunnel deepens, and what began as emptiness continues to fill with the quiet shapes of newborn galaxies. Candles learn to hold their flame steady enough to measure space. Nearby, Cepheid variables keep time with brightness, their periods turning into powers. Farther out, Type Ia supernovae bloom with a regularity that can be tamed by light curve shape and color, a standardizable candle whose corrected luminosity lets distances ladder outward. With each rung, the calibration passes from parallax to Cepheids to supernovae. With each pass, small biases are folded back and trimmed. A modern ledger adds more steps still. The tip of the red giant branch, surface brightness fluctuations, Tully-Fisher and Faber-Jackson relations, the fundamental plane, even water megamasers in the disks of a few lucky nuclei. But the rhythm remains. Anchor, transfer, extend. The accepted physics is simple to say, intricate to keep. Type Ia supernovae arise from thermonuclear ignition in degenerate stars, most often carbon-oxygen white dwarfs. Their peak brightness correlates with how quickly they fade, and after correcting for stretch, color, and a small host galaxy mass, step, they settle into a candle bright enough to be seen across much of the observable universe. Cross-calibrated to Cepheids, or to red giant tips, thousands of such explosions place galaxies on a narrow Hubble line where recession speed and distance grow together. The slope in that line, translated into present-day units, is the Hubble constant, H0, a number that turns QMS1 MPC1 into the day-to-day expansion rate of space. A lesser-known household detail hums beneath the grandeur. The most trusted geometric anchor for the zero point is a spiral galaxy with a warped, sub-parsec water-maser disk, NGC 4258, whose Keplerian rotation has been mapped spot by spot. Its distance, measured without candles at all, sets the absolute scale for Cepheids, red giant tips and supernovae in the same ledger, a quiet hinge upon which many billions of light-years swing. Uncertainty keeps its even voice and does not hurry the listener. Diversity among Type Ia progenitors, residual dust laws in their hosts, and the color-luminosity relation's exact form inject small systematics. Crowding and background light complicate Cepheid photometry in spiral hosts. Metallicity alters, zero points by amounts that must be modeled rather than assumed away. Even the red giant tip shines with an edge that softens in metal-rich populations and requires band choices that trade sensitivity to dust for sensitivity to composition. Each method works, each method leans on calibration, and there's small disagreements. are measured in a few percent that matter. Soft ironies sit down one by one. The most useful supernova are the ones that refuse to be identical but oblige us by being correctable. The mass step that complicates the candle's simplicity ends up stabilizing it, once admitted and accounted for. And the grandest number. On the ledger, the expansion rate of the universe today is sensitive to the least glamorous chores, photometric zero points, background subtraction, and knowing which stars in a crowded disk truly pulsate. A modern tension keeps its poise and tests assumptions without drama. When the distance ladder is anchored with Cepheids and carried through Type Ia supernovae, recent analyses using new near-infrared images from JWST, higher resolution, less crowding, gentler dust, confirm local values around 72 to 73 Coentler S1 MPC1, closely matching earlier HST-based results. From the early universe, however, the Planck satellite's picture of the cosmic microwave background interpreted in flat LCDM infers H0 67.4 Coentler C1 MPC1. Between those two great numbers lies a gap larger than all quoted errors, a calm contradiction that refuses to be rounded away. A third, independent yardstick steps between them with its own tempo. Using the tip of the red giant branch as the local anchor, a sharp cutoff in old star luminosity that is less sensitive to dust and crowding, recent JWST-based determinations gather around 69 to 70 km/s1 MPC1 when tied to the same supernova hosts and to the NGC 4258 Maser distance. The result sits midway, closer to the early universe value than the Cepheid ladder, yet not identical to it, a gentle nudge that says systematics are small, not gone. The large-scale yardsticks agree with the early universe side of the story. Baryon acoustic oscillations, a fossil ripple from the plasma epoch, traced exquisitely in new DESI maps and combined with well-measured early universe physics, lean toward H0 6869 km/s1 MPC1. The numbers lock together with the microwave background like gears set at arm's length. Different epochs, different methods, similar answers. The Webb's standard ruler is broad rather than sharp, but in sums over millions of galaxy pairs, it stays steady. Time delay cosmography offers a parallel bridge. In a strong gravitational lens, a multiply-imaged quasar flickers, and the delayed echoes between images measure a difference in path length that, when the lens mass is modeled with care and the line of sight is properly weighted, yields H0 without a distance ladder or a cosmic sound horizon. The method's current results remain precise per system and mixed in ensemble, with central values that can tilt either side of the gap depending on modeling choices, selection, and shear. Still, with growing samples of lensed quasars and supernovae, the technique matures into a third pillar with different systematics than both ladders and ripples. A gentle analogy visits and recedes. 3 yardsticks lie on a long table. One carved from local wood, one from timber carried in from a distant shore, one from a bundle of reeds braided from many streams. They do not match to the millimeter. The carpenter does not panic. She checks each against objects she trusts, shaves a sliver here, rebraids there, and leaves a note to revisit after the wood has rested. 3 more soft ironies make themselves at home. The most precise number in everyday cosmology is the one whose methods disagree cleanly, a precision that clarifies rather than comforts. The newest telescope, built to peer into the first galaxies, spends much of its time remeasuring nearby stars to test a century-old ladder. And the early universe, faint and far, sometimes sets the present faster than today's brightest supernovae do. The accepted processes remain trustworthy even as the tension holds. Parallax anchors Cepheids directly. Cepheids and TRGB tie to supernovae. Supernovae carry the local slope of the Hubble relation outward. On the other hand, The early universe route marches from the microwave background's angular scale through a model that has passed many tests: nucleosynthesis, large scale, structure, lensing, to an inferred H0. That the two routes differ is an empirical fact. Whether the difference demands new physics or reflects remaining, subtle systematics is the open question the field respects. A small, tactile detail persists amid the abstractions. JWST's microshutters open onto Cepheid fields where HST once blurred, crowding eases, background spirals resolve. The same stars, counted again in cleaner light, reassure rather than overturn, and the distance ladder's steps feel less slippery under a colder mirror. In the other direction, robot fiber positioners spend clear nights drinking spectra for Desi's acoustic ruler, their quiet shuffles building a meter stick from the sum of many small sips of redshift. The machinery is fussy and calm. The universe gives what it gives. Mystery remains seated, composed. If the tension survives improved calibrations and richer samples, Cepheids checked in more hosts, TRGB in redder halos, lensed quasars and supernovae modeled with deeper images and kinematic. Priors, BAO refined with yet larger volumes. What is the smallest change to the standard model that could reconcile the views? Extra radiation in the early universe, subtle dark energy behavior, or interactions in the dark sector have each had their turns on the stage. None yet keeps all the other successes intact without new strains appearing elsewhere. The fields. Patience, like its ladders, is built step by step. A few dry observations stay near the ledger. Scaling relations, Tully-Fisher for disks, Faber-Jackson, and the fundamental plane for spheroids, remain sturdy mid-range tools but cede the sharpest cosmology to candles and rulers. Surface brightness fluctuations work quietly in the nearby universe, whispering distances to smooth old populations with admirable stability. And massers, though rare, are priceless. Every new geometric distance is a calibration lantern hung along the road. The night does not choose sides. A fact holds. Standard candles and standard rulers now place the present expansion rate with percent-level precision by different routes, with Cepheid-calibrated supernovae favoring U-Mickey 73, early universe and BAO routes favoring U-19 69, and TRGB-based ladders leaning toward the middle. A small, grounded detail persists. The Masser in NGC 4258, a rotating ring of water a few light-years from a black hole, quietly sets the zero point that many methods share. A mystery remains, whether the gap is the signature of new physics or the residue of small systematics that survive careful work. In that measured openness, the yardsticks stay tensed, the candles keep their steady beat, and the universe continues to expand whether counted by ladders, ripples, or delays. Edges of the Atlas curl where categories fail. Some galaxies spread out like breath on glass, so diffuse that moonlit clouds would outshine them. Others compress into knots only a few dozen parsecs across, brighter than globular clusters and heavier too. A few carry rings tilted like halos, polar disks running at right angles to the host, while others stretch into giant low-surface brightness disks whose outskirts keep going after photographs give up. These outliers, ultra-diffuse, ultra-compact, polar ring, and the wide family of low-surface brightness systems, ask the tuning fork to whisper instead of declare. They stand as facts, real, common enough to matter, and awkward for tidy schemes. A scientifically accepted thread links many of them. Surface brightness, not total luminosity, decides whether a galaxy is easy to find. Surveys that push the sky background lower reveal populations our instruments once walked past. Dedicated arrays with baffled wide-field lenses and anti-reflection. Coatings suppress scattered light and ghosting so thoroughly that the night's true faintness appears. In their images, ultra-diffuse galaxies the size of the Milky Way's disk but 1,000 times dimmer glide into view, especially in clusters where tides and harassment puff dwarfs and peel gas. Their half-light radii are large, their stellar masses small, their central brightness low. Yet they are galaxies all the same, with stars, globular clusters, and dynamics that must be weighed. A lesser-known, tactile detail lives in the optics. To chase faint outskirts, some instruments stack many commercial telephoto lenses, each with nanostructured coatings that swallow glints. Every lens sees the same sky, and their images code, while their residual ghosts and internal reflections average down. Baffling and black paint reach into corners. Flat fields are built from long night sky sequences rather than bright domes. Focus is locked with shims. Even dew heater currents are filtered to keep micro-vibrations from writing patterns into the background. Low-surface brightness astronomy is half sky and half housekeeping, a domestic art devoted to the dim. Uncertainty keeps an even seat. What, precisely, makes an ultra-diffuse galaxy? Are many simply dwarfs that stellar feedback has expanded, heating and stirring stars into broad orbits? Are some failed giants, their halos as massive as L systems but star formation stunted early by environment or early outflows? Do cluster tides inflate a subset, or does ram pressure quench them before they ever compact? Individual cases argue for several channels. Samples argue that more than one route is open. Even their dark matter content resists a single sentence. Some ultra-diffuse galaxies carry rich systems of globular clusters that hint at heavy halos, while others look dynamically modest when distances and inclinations are revised. The ledger allows plural origins without impatience. Soft ironies arrive and stay. The largest galaxies on the sky can be among the hardest to see. The emptiest-looking disks sometimes host the most globular clusters per unit starlight. Richness, hiding in poverty. And the systems that most reshape ideas about formation are not the spectacular spirals, but the smudges that photographs once cropped away as background. Ultra-compact dwarfs stand at the other extreme. They crowd a few 100 million to 1 billion suns into spheres tens of parsecs across, kinematically hotter than globulars, sometimes metal-rich, sometimes showing central mass excesses that hint at stripped nuclei. In clusters like Fornax and Virgo, they gather near giant galaxies as if to confess a tidal origin, the threshed cores of once larger companions whose envelopes were removed by long encounters. Others look more like the high-mass tip of the star cluster distribution. Two pathways again fit, nature grows some. Nurture reveals others by carving them free. Polar ring galaxies pose a kinematic gift. A central disk turns one way, an outer ring or disk of gas and stars orbits on a perpendicular plane. Measure both, and the three-dimensional shape of the dark halo comes forward, oblate, prolate, or triaxial, because the two planes sample the gravitational potential from different angles. Accretion or minor mergers likely lay down the ring. Stability over gigayears suggests quiet halos that do not twist too quickly. Each system is a wind tunnel for a shape that light alone cannot show. Giant low-surface brightness disks extend. The quiet to absurdity. Star formation per area follows the gas. Where gas thins, the Kennicutt-Schmidt law moves into a regime of patience, and blue knots sprinkle anemic arms across tens of kiloparsecs. Some of these giants hide only because the sky is bright, once the background is understood well enough, to be subtracted without bias. Their faint outskirts step forward and change what typical means for disks. Their rotation curves remain flat into very low brightness, reminding the ledger that halos hold even when stars do not. A gentle analogy drifts through and leaves. Outliers are like the faint edge of a frost pattern on a window pane, the place where the eye, having stared at the bold veins, realizes the boundary is not clean but feathered, fine structures branching. into cold air, continuous with the main but different in mood. The analogy helps only briefly. Frost grows in minutes, galaxies in eons, yet both teach that edges deserve a closer look. Mystery keeps several boxes open. Do ultra-diffuse galaxies in the field differ fundamentally from those in clusters, or are they the same family shaped by different weather? What fraction of ultra-compact dwarfs hide black holes left from their parent nuclei, and what does that fraction say about the building of galaxy centers? How often do polar rings arise from smooth gas accretion along filaments rather than from encounters, and how long can they endure? And for the very faintest low-surface brightness systems around large hosts, satellites that look like loose handfuls of stars, what combination of tides, feedback, and halo structure sets their shapes and survival times? 3 more quiet ironies settle. The best laboratories for dark halo geometry are not the symmetric galaxies the tuning fork admires, but the misaligned ones it labels with hyphens. Galaxies that look most like nothing in particular, pale, smooth, and sparse, become the strongest evidence that surface brightness selection has edited our senses for a century, and the most conservative act in imaging, refusing to push contrast for aesthetic drama, unlocks the most radical results because the outskirts only appear when the temptation to beautify is resisted. Accepted processes keep their center. Selection effects decide histories as surely as physics does, because what is not seen is not counted. Improve flats, model scattered light, and integrate longer, and the universe changes composition without changing itself. In dynamics, mass follows not light but potential. Outliers are simply different entrances into the same field, tracing the outer contours where the fork's inner grammar fails. A small, craft-level fact persists. In the lowest brightness images, even the rubber of a camera's internal seals matters. Outgassing fogs the first minutes of a night and leaves a gradient that imitates a disk. A distant bright star, well outside the frame, can throw a leaf-shaped ghost that looks for all the world like a shell. Only rotation of the camera or a second night frees the truth from the instrument. The dimmest galaxies force the cleanest. Habits, irony bows once more. Grand surveys built to harvest redshifts by the million also deliver the background control needed to find fuzz. The galaxies most likely to revise formation stories are the ones that do not fit on posters. And the word defect, once used loosely for these departures from the fork, becomes clue as soon as models admit that growth can puff or strip, torque or tilt, starve or feed, in many ways that land on the same plane at different angles. A fact holds: edge cases, ultra-diffuse, ultra-compact, polar ring, and low-surface brightness galaxies are robust, measurable populations that complicate simple morphologies and test ideas about feedback, tides, accretion, and hello shape. A quiet detail persists. Instruments built to suppress scatter and honor the sky background with almost domestic care reveal most of them, suggesting that discovery is as much about subtraction as about exposure. A mystery remains. How the mix of channels that make each class varies with mass and environment, and how many yet undetected systems still lie below today's thresholds. In their company, the atlas stays honest. The tuning fork hums but does not command, and the map of galaxies keeps a calm margin where faintness edits slowly and the universe writes in a fine hand. The home river clarifies into parts. What looks like a continuous band by eye reveals a barred spiral when traced in infrared counts and stellar motions. A central bar angled modestly to the sun center line, a bulge shaped like a faint X, thin and thick disks layered like pages, and a halo, laced with streams from past visitors. The Milky Way is not a picture, but a moving arrangement. Kinematics becomes cartography. Red clump giants outline the bar. Maser parallaxes in high-mass star-forming regions stitch spiral arms across quadrants. Chemical abundances paint a quiet, gradient outward and a sharp divide between old, alpha-rich stars and younger, alpha-poor ones. In this way, the old river is learned as a city with districts. A small, lesser-known detail sits in the core. Along sightlines nicknamed with the politeness of tradition, Bod's Window for one, the bulge shows a split red clump, a telltale of the peanut or X shape that bars often grow when a disc buckles. The split is not a metaphor. It is a brightness histogram with two humps, one nearer, one farther along the bar's tilted spine, as if the bulge were a lantern with two panes. Microlensing surveys through this same field quietly record the motions of stars in front of and behind, their timescale distributions whispering the bar's rotation without a single galaxy-wide image in hand. Uncertainty keeps its seat in the middle distance. The exact pattern speed of the bar, fast or only moderately so, slides within bounds set by stellar streams in velocity space and by resonances that carve gaps among local orbits. The number and continuity of large-scale spiral arms change slightly with every new tracer. Masers, young clusters, dust extinction, star counts in the near-infrared. The warp of the outer disk lifts and dips unevenly, and the culprit, tides from satellites, misaligned infall, a torque from the halo's shape, shares credit without settling the bill. Even the halo's geometry around the bar remains, a shade uncertain, traded between oblate and triaxial in models that fit some data better than others. Soft ironies arrange themselves and do not move. The nearest grand spiral is the hardest to draw, because being inside a thing is the best way to forget its outline. The same dust that makes the Milky Way beautiful to the eye hides the very structure needed to call it by its proper name. And the most decisive global inferences come from local small motions, centimeters per second of Doppler shift in millions of stars, so that the map of a galaxy is written in the margins of spectrographs. The thin disk carries the present tense. Cold, rotationally supported, it holds spiral structure and most of the star formation. Its chemistry shows a gentle decline in metallicity with radius and small ripples where past spiral arm passages and migrating stars have mixed neighborhoods. The thick disk speaks in a lower register, kinematically hotter, older, alpha-enhanced, rising above the mid-plane like a quiet mezzanine. Its origin remains a layered story. Early violent stirring, a major ancient merger, secular heating, radial migration, not one switch but many, their contributions varying with radius and time. Observationally, its distinct sequence in the plane of A phi versus phi h looks like two lines written by the same hand with different pens. A gentle analogy helps and leaves. The galaxy is a city inferred from its commuter traffic. Where speeds shift, a bridge must lie. Where directions split, a rotary turns. Where velocities curl into loops, a stadium or market pulls. The analogy holds until it does not. Stars do not decide, gravity does. Yet the sense that motion writes the map is allowed to linger. Gaia's sky-filling ledger turns the local neighborhood into a classroom. In the plane of vertical position versus vertical velocity, nearby stars draw a spiral, a snail shell, of phase mixing, evidence that the disk was nudged a few 100 million years ago, likely by the Sagittarius dwarf's last pass. In the plane of radial versus tangential speed, streams such as Hercules, Hyades, and Sirius sit where bar and spiral resonances shepherd orbits, dynamical weather written as arching ridges. The lesson is not dramatized. Equilibrium is an approximation. The galaxy respects only on average. The disk rings a little as it turns. The halo carries longer memories. Wide rivers of stars, Sagittarius wrapping around the sky, GD1 stretched fine, the Helmi stream, the orphan, record the slow dissolution of smaller systems in the Milky Way's potential. Their widths, densities, and gaps constrain the shape and lumpiness of the dark halo. A missing mass here, a narrowness there, hint at subhalos too dim to find by starlight. Deeper within, the inner halo tells of one large, ancient merger, debris with high radial orbits and distinct chemistry known by twin names in the literature, a reminder that events can leave more than one signature and more than one brand. 3 dry observations keep to themselves. The Orion Cygnus spur that hosts the Sun is not the grandest arm, yet proves the most catalogued, a local street mistaken for a highway by those who never leave town. The large Magellanic Cloud's mass raises a wake in the Milky Way's halo, slightly tugging the reflex motion of stars on one side of the sky more than the other, a present tense disturbance in a structure often treated as static. And the Magellanic Stream, an HI ribbon arcing far beyond the clouds themselves, binds our galaxy and its companions in a shared weather system, a trailing whisper of recent travel. Accepted processes hold the ground beneath the terms. Secular evolution thickens bars and moves stars across resonances without gas required. Radial migration sends old, metal-rich stars outward and young, metal-poor stars inward with little, heating, smoothing gradients while preserving chemistry's memory. Inside-out growth leaves older populations centrally concentrated and younger ones sprawling like newer suburbs. Spectroscopic surveys, apogee in the infrared, Gala and Lamost in the optical, others in the south and north, turn abundances into family names, chemical tagging that recognizes siblings long after their cluster has dissolved. A small tactile detail clings to the bar, infrared star counts taken through windows where extinction thins show the bar's near end leaning into the first quadrant. The far end sinks into the fourth. The asymmetry in brightness along longitudes is not a trick of dust alone. It is geometry, as if a beam inside a lantern were tilted a few tens of degrees. The peanut shape above the plane appears again in red. Clump splits, so the bar is not just length and angle but thickness and buckle, an object with a history of its own. Mystery keeps a patient question, or 3. Exactly how many long spiral arms the Milky Way maintains continuously, and whether the local arm is a spur, a branch, or a major segment, adjusts with each new parallax to a star-forming region. Whether the thick disk came chiefly from an early, gas-rich, turbulent phase or from an external jolt that heated an already settling thin disk remains a matter of proportions rather than of possibility. And the halo's global shape, rounder inside, flatter outside, or triaxial with the bar, waits for streams longer, colder, and counted with still finer precision. Irony steps forward again and keeps its voice low. To learn the galaxies, future, one listens for a faint spiral in local vertical motion, a pattern drawn by a past encounter that is still ringing. The more precisely surveys measure the Milky Way, the less steady it appears, so accuracy replaces a calm picture with a livelier one, and the story that moves the sun off the center, the one that freed minds from a flattering symmetry, now places the sun with care on a minor arm, an address humble enough to be useful. The outer disk lifts like a slow wave. In 21 centimeter, maps, the warps flare. In star counts they echo faintly. In velocities they twist. The causes combine. Torques from satellites, a halo not quite aligned, gas arriving with angular momentum askew. The warp is not a defect but a motion, a low-frequency mode that persists so long that it feels like architecture. Near the edges, flares broaden the disk. Stars breathe with taller steps. The frontier is not sharp. The center keeps its quiet. Engine. SGR-A murmurs now, yet the lobes above and below the plane, gamma-ray balloons, X-ray shells, hint at brighter hours. The bar may feed it, or the central 100 parsecs may cycle gas through starbursts instead, each episode leaving light echoes in ionized clouds. The nucleus takes notes even when it sleeps. A fact remains. The Milky Way is a barred spiral with thin and thick disks, a buckled, X-shaped bulge, a warped, flaring outer layer, and a halo woven with streams from long ago and ongoing accretion. A small, precise detail persists. A split, red clump along certain bulge sightlines marks the peanut shape of the bar as clearly as a shadow marks a hinge. A mystery endures. The bar's exact pattern, speed, and reach, the spiral's true plan, and the proportions by which mergers, migration, and early turbulence built the thick disk. Between them, the river in the sky becomes a map underfoot. Understanding widens by motions more than by pictures, and the home galaxy continues to turn, patient as ever, while the species inside it learns to name the currents it rides. Night folds its edges inward until the dome feels smaller than before. The river of the Milky Way lies where it always lies, pale and exact, as if nothing has been said about it. The air cools by a degree. The ground releases a little stored warmth. Lenses give back their faint ghosts and go clear. A slow turning. Earth carries the band from one window to another without asking anyone to follow. Facts loosen their grip and become textures. Dust is only darkness again. Hydrogen is only silence with a wavelength tucked inside it. A distant nucleus rests as a dim star that does not need a name. What once stands as a diagram returns to a smudge, and the smudge is enough. A small detail stays behind like a bookmark. Somewhere, a graphite ring on an old plate still encircles a variable, and the ring is as quiet as the halo around a moth. On glass. It does not call attention. It simply remains. Mystery does not pose questions now. It is a soft interval between breaths, a pause where the sky seems to listen to itself. The outer parts of a disk do not ask why they warp. The first light in the far distance does not announce when it began. The bar in the center does not settle on a single speed. It drifts, like thought in the last minutes before sleep. Earnies let themselves fade. The curve that should fall remains flat and then is only a line folded back into night. The brightest engines dim to embers and then to habit. The largest patterns return to frost on a window that no one looks through. Stars continue to cross, the meridian at their appointed times. A shutter closes, a notebook cools, a dome comes to rest with the slit turned away from the breeze. Overhead, the river keeps its unbroken course, and nothing hurries. Light travels, time passes. The planet turns. End of script. Sleep well.